Very good morning, dear friends. Today is the fourth day of this short-term course. Today we have expert from NIT Kurukshetra, National Institute of Technology Kurukshetra, Professor Joy Prakash Mishra. He will be delivering a lecture on hybrid machining processes related to chemical, mechanical, thermal, and this related to anything. Okay. Now I just before going to deliver his lecture, I just want to give his brief introduction. He has graduated BTech from Kalyan Engineering College from Kolkata, that is, and he did MTech from Indian Institute of Technology, Roorkee, and thereafter immediately he has done his PhD in the area of advanced machining, that is electrochemical honing of gears. Okay, he has done recently. He recently passed out PhD from Indian Institute of Technology, Roorkee. Now he is guiding 5 PhD candidates in the area of machining area. So that may be conventional or non-conventional, and he is guiding MTech students also. And he is in his credit, he is having 42 publications, including journals and including conference papers, international, national level. So now I invite Dr. Joy Prakash Mishra to deliver a lecture on this hybrid machining processes. Thank you.
Thank you, sir. A very warm morning to one and all present over here. Myself, Joy Prakash Mishra, Assistant Professor in the Department of Mechanical Engineering, NIT Kurukshetra. And today we will discuss about hybrid machining process. This is our today's topic. But before going to the results, till date I think the lots of different aspects of advanced machining process has been discussed. So that today we will discuss a step ahead than advanced machining processes, that is hybrid machining processes. So before going into the details, I just show you the contents of this presentation. My presentation talk consists of these 5 subsections. First one, the introduction part, in which we discuss about the basic fundamental concept of machinings, and then history of machining processes, how it comes, machining, then advanced machining, and then one step ahead, that is hybrid machining process. Then hybrid machining processes. In this subsection, we will discuss about the definitions, characteristics, different types of hybrid machining processes, and their properties and their performances. And finally, electrochemical honing. We will discuss in detail this process. Basically, this is an example of hybrid machining process, and during this section, you can find how hybrid machining processes are beneficial for our present day scenario. And finally, we will draw some conclusion and future scope for the research work. So before going into details, it is better to just recall or remember the basic fundamental concepts of the machining process or manufacturing process. Now the first question is that what is manufacturing, or what do you mean by manufacturing? Don't take this session as that I am delivering a speech or delivering a lecture. This is interactive session, and I need that input from both the sides, from my side and from your side. So my first question is, what is manufacturing, or what do you mean by manufacturing? Any answer? Yeah, good. Basically, manufacturing process is the method to convert raw materials into finished products. Okay. Raw material into finished products. On the input side or the left hand side, raw materials are there. On the output side, finished products are there. If we wish to convert raw material into finished product, we have to pass through some methods, and these methods are nothing but manufacturing processes. Besides these materials, to convert the raw material into finished product, we need man, machine, and money. Man is labor, machine, and money. These raw materials, man, machine, and money, and methods, these are known as 5M of manufacturing. Okay. So now coming to the classification of manufacturing process, on the basis of how we get the final object from raw material, on the basis of that, this manufacturing process is classified in 4 groups. First one is the additive type. Additive type means in which we get the final object by addition of material. For example, casting. In casting, what do we do? Normally, just melt the metal, and then we prepare the mold cavity. We pour that metal in the cavity, allow it to solidify, and we get the final object. For example, RP. RP is also an example of additive type, in which we get the final object by adding the metal layer by layer. Next part is, the next classification is formative type, in which we get the final object by deforming the material. This deformation is obviously plastic deformation. Normally two type of deformation is there. One is elastic and another is plastic deformation. If it is if we recall the stress strain curve, if it is below elastic limit, then that is known as elastic deformation. If it is above or beyond the elastic limit, then it is plastic deformation. If we remove the forces that is applied on the material beyond in between elastic limit or up to elastic limit, the material springs back to its original shape. But this scenario will it is not accordingly in case of inelastic region or plastic region. In case of plastic region, if we apply force and that force amount of force is beyond elastic limit or elastic region, we will get a permanent deformation or plastic deformation or permanent set. In case of formative type processes, this deformation is plastic deformation. So basically, or we can define this type that formative type of manufacturing processes those in which we get the final object by plastically deforming the raw material. For example, rolling and forging. Next type is subtractive type, in which we obtain the final object by removing the metal. And finally, that is assembly type, that is final, in which final object is obtained by joining of material. For example, welding. So our that main focus, that is machining, that comes under subtractive type group. Now, what is machining? Machining is basically a subtractive type manufacturing process. Obviously, it is used to remove the metal by in the form of chips to impart desired size, shape, and finishing to the final product by using suitable cutting tool and using suitable relative motion between tool and workpiece. So the main highlight of this definition is that suitable cutting tool. Now, why suitable? If we use in this definition, if we use only cutting tool, if suitable is suitable, the word suitable is missed, then what will happen? Any guess? Why suitable? If your definition is that using cutting tool, then is it okay or not?
It's only a requirement of the process which you do.
Requirement of the process and requirement of the workpiece. Actually, we on which workpiece we are doing the work. On the basis of that, we have to choose the workpiece. We have to choose the tool wisely. Suppose for there are three examples are there: turning, one drilling, and third one is milling. We are very much familiar with these processes. Okay, but for example, turning. And if we wish to turn a stainless steel material, so we have to choose any tool that is harder than the stainless steel. Okay, we normally use carbides. Okay, so if we use copper as a tool, then is it possible? And the answer is obviously no. Why? Because if we check the basic process principle or the mechanism of material removal in material or in machining, then we can we can observe it that the material is removed by shearing action due to severe plastic deformation, and this plastic deformation is caused by tool as it compresses the workpiece, and therefore the tool should be the harder than the workpiece material. And this is the main drawbacks of conventional machining processes. Conventional machining basically lathe, grinding, drilling, milling. These are the basic fundamental. The main drawbacks of these processes are that tools should be harder than the workpiece, and therefore these processes are having material hardness limitation. Okay, if you using mild steel, then HSS is good, no problem with that. If we use titanium, then we have to change the inserts or we have to change the tool. So there is a material hardness limitation in these processes. Clear? So here AMPs come into picture. Okay. So I'm not that good at delivering lecture, but my main objective is to share my knowledge and finding on hybrid machining processes, to encourage the global research community to carry out research in this field, to mature the process and to make these processes commercialized. So before going into details, I just wish to show some pics. Any guess? These pics indicate an international event, great international event. Any guess? World War II, obviously World War II. Okay, Hitler is there and fighter planes are moving. So And this is the most darkened phase of Second World War, that is explosion of Hiroshima. But besides this nightmare of human civilizations, this Second World War compelled us to think in a different way. And these are the some of the colorful after effect of Second World War. That is development of automotive industry, development of aerospace industry, development of marine industry, satellite industry, nuclear power plants, etc. But the components used in these industries are operated in a very hostile environment. And for that, this hostile environment means high working temperature, high working pressure. So if we use the conventional materials like steel and aluminum for this type of operations, so what we'll get? We will get only failure. So we have to choose, or we have to generate, or you have to invent new materials or non-conventional materials. Okay. So we can say that the development of advanced technological industries has been accompanied by very hard, high strength, difficult to machine materials. And these are, for example, stainless steel, super alloys, titanium, composites, and ceramics. Stainless steel is basically common to us. Stainless steel is basically chromium and nickel are there, which iron, and it will improve the corrosion resistance and wear resistance property of the steel. Next part is super alloys. Super alloys are alloys of iron, cobalt, nickel based alloys, and these are having super qualities basically. Super qualities in terms of high strength, high keep resistance property, high wear resistance property. For example, Incolloy, Inconel. Then composites. Composites are a mixture of two or more chemically insoluble and physically distinct phases. Okay. For example, roof. That roof, RCC. We use cement and TMT bar to produce this roof. Thus, we will add the tensile strength and compressive strength together. Okay. Similarly, you use presently in automobile industry that plastic is used, but in presence of glass reinforcement. If we use plastic, the strength or the melting temperature is very low in case of plastics. So we have to need this type of material that will provide this phenomena, that high strength and high temperature, high melting temperature, as well as the high strength to weight ratio. In case of plastic, strength to weight ratio is good. If we go for metal, the strength to weight ratio not at par like plastics. So we have to choose such material that will provide the high strength to weight ratio as well as high strength and high melting temperature. And therefore we reinforce glass beads or glass fibers in the plastic, and then and thus we will produce a composite, that is glass fiber reinforced plastics, and that can solve our purpose basically. Then ceramics are basically inorganic compound of metallic and non-metallic elements. In case of metal, just for discussion, in case of metal, the bond is, which type of bond is there in metals? Not in covalent, it is metallic bond in case of metals. In case of metals, that is metallic bond, but in case of ceramics, covalent bonds are there. Okay. So this covalent bond, the strength of the covalent bond is higher than the metallic bond, and that's why the ceramics, for example, aluminum oxide, silicon carbide, these are having high melting temperature and high strength. Okay, high refractoriness, high modulus of rigidity. So these are as we need materials which have to be operated in hostile environment, and therefore you have to generate new materials or non-conventional materials. For example, this. So these materials are high strength to weight ratio and low machinability, because strength is high, hardness is high. That way, so producing complicated geometries or maintaining close tolerances in these materials is found very much difficult, and for there, this necessitates the exploration of advanced machining processes. In case of conventional machining, the fundamental concept of the machining process is done by mechanical abrasion or by friction, mechanical friction, and therefore always tool and workpiece always remain in contact, and therefore tool should be harder, otherwise tool will worn out. Okay. But in case of advanced machining process, the energy sources used to remove the material or the mechanism of material removal is completely different from the conventional techniques. And on the basis of which type of energy sources is used, this advanced machining processes, also in short it is also known as AMPs, are classified in 4 groups: mechanical type, chemical type, electrochemical type, and finally thermoelectric type. In case of mechanical type, material is removed by erosion by high velocity particles. For example, AGM, which stands for abrasive jet machining, or USM, that is stand for ultrasonic machining. Then chemical type, in which material is removed by corrosive action of reagent, chemical machining, and photochemical machining. Then electrochemical machining, for example, in which material is removed by ion displacement. For example, ECM or ECD. ECM stands for electrochemical machining, and ECD stands for electrochemical drilling. And then finally, the last one, that is thermoelectric type, in which metal is removed by fusion and vaporization. For example, EDM and EBM. EDM for electric discharge machining, and EBM electron beam machining. So still now it is clear, I think. Anytime you find any doubt, just raise your hand, because I like to be interrupted. So moving on. This is a list of different types of AMPs. They are mechanism of material removal, transfer media, and energy sources. For example, AGM and USM, abrasive jet machining and ultrasonic machining, which comes under group of mechanical type. The mechanism of material removal is erosion, and energy sources used are mechanical or fluid motion. For example, ECM, that comes under electrochemical group, in which material is removed by that power sources used is electric current, and material is removed by ion displacement. Chemical machining or photochemical machining, that comes under chemical group, in which mechanism of material removal is corrosive action of chemical reagent. And the last one, thermoelectric type. Here subgroups are there. So many subgroups are there. For example, EDM, the energy sources is electric arc. For EBM, energy sources is high speed electrons. For LBM, that is laser beam machining, this is powerful radiations. IBM, ionized substance. And for PAM, that is plasma arc machining, ionized substance. Okay. For IBM and PAM, the energy sources are same, but the transfer media is different. For IBM, it is hot gases, while in PAM, it is ion stream. This is a comparative study of different AMPs basically. If we check the power requirement, then we will find that ECM, electrochemical machining, and the plasma arc machining is having highest power consumption. ECM required high amount of ampere, and that's why this power is 1 lakh watt. Okay, but the surface finish that can be achieved by ECM is highest among these machining process, these advanced machining processes, and it is near about 0.1 to 2.5 micron. Okay, in case of ECM, the material is removed by ion displacement and at atomic scale, and therefore this is the value of surface roughness. So we'll discuss, just briefly discuss different machining process one by one. First one is that USM process, or ultrasonic machining. A transducer is there. Transducer basically used to convert any energy in defined form of energy. In case of US, this transducer is used to convert electrical energy into mechanical vibrations. Then this, it's not working. This tool cone is there. This is also known as sonotrode or horn. This is convergent in shape. It is used to amplify the generated vibration to the tool, or transmit the vibration, amplified and transmitted the vibration to the tool. A pump is there to supply the abrasive slurry to the cutting zone. Normally, transducer used in USM are either piezoelectric or magnetostrictive. I think you know about piezoelectric and magnetostrictive. Piezoelectric means normally that type of transducer which convert force into electricity and vice versa. If we use electric field, we will get a deformation or strain. Okay, magnetostrictive is for magnetic field or vice versa. If we use magnetic field, we will get straining. If we use strain, then we will get magnetic field. So normally in case of USM, the transducer used are either piezoelectric or magnetostrictive. So the process principle of this technique is that a vibrating tool that oscillating at ultrasonic frequencies is used to remove material from the workpiece, added by an abrasive slurry that flows freely between the workpiece and the tool. As the tool vibrates, this pushes down the abrasive slurry, a liquid containing abrasive grain, until the grains impact the workpiece, and because of brittleness of the workpiece and the impact of abrasives, it erode out. Okay. So this is the fundamental concept or the fundamental principle of ESM process. Moving on, this is abrasive jet machining. Here, compressor air or gas supply is there, high pressure gas supply is there, and this abrasive supplier is there. Okay, and here mixing is done. This then finally what will happen, that abrasive, this air, high speed air laden abrasives impinges on the workpiece surface and erodes it by brittle fracture. Okay, this is used as protective marks to choose the workpiece or to cut the workpiece selectively. If you don't want to cut some portion, then we have to use protective mask. Okay, it will protect the effect of this cutting action. So the principle of this technique is that a focus stream of high, हाँ, एयर भी यूज हो सकता है, कोई प्रॉब्लम नहीं. हाँ, compressed air यूज होता है क्योंकि हमें स्पीड को कंट्रोल करना है, हाई स्पीड चाहिए, so that can carry that abrasive particles. Okay, and therefore any type of gas can be used. CO2 also can be used, nitrogen gas can be used, but for economical purpose we only use compressed air. So the basic fundamental concept of this technique or this process is that a focused stream of high velocity abrasive particles laden in a carrier gas coming out of the AGM nozzle and impinges on the target surface and erodes it. The impact causes a tiny brittle fracture and carrier gas carries away this metal debris. The resulting erosion can be used for cleaning, cutting, debouring, polishing and drilling purpose. The process is more suitable when work material is brittle or fragile. These techniques, this USM technique and AGM technique are mainly used for ceramics or glass. Glass is also an example of ceramics. If it is glass, basically transparent ceramics, we can say that. So if we cut any ceramic material or glass, we have to go for USM or AGM process. Next technique is that is AWJM, that is abrasive water jet machining. So abrasive water jet, in AGM we use high velocity gas. In case of AWJM, in place of that gas we use water supply, water jet. Okay, so here abrasive supply is there, your water supply is there, mixing is done here, and finally that abrasive water laden abrasive impinges on the work surface and erodes it. So the process, if we discuss the different principles of this process, that this process combines the principle of WJM and AGM. WJM basically water jet machining, in which we use the kinetic energy of water jet to cut the material. The process principle of AGM and WJM and AWJM are almost similar. So the difference is that the transfer media. In case of AGM, transfer media is high velocity gas, and we mix abrasive with that. Okay. In case of WJM, only water is there and high velocity water. That kinetic energy, as it impinge on the work surface, the kinetic energy convert in the kinetic energy of water jet will convert in the other form of energy or heat energy, and it will do the cutting actions. Okay, and finally, and same for AWJM. In AWJM we just combine the principle of AJM and WJM. So combine the principle of WJM and AJM process to create a unique process in which materials is removed due to erosive action of an abrasive laden water jet. This is high velocity water jet in combination of abrasive particle, as we discussed in the last slide, produces slurry cutting jet. Stream of small abrasive particles is introduced and entered in the water jet in such a manner that the momentum over water jet is transferred to the abrasive particles. This technique can be used to cut metals, ceramics and glasses up to thickness of 20 centimeter at high speed. And this ability that it can cut 20 centimeter thickness, 20 centimeters thick is a large thickness, I think, and this is due to the re-entertainment of abrasive particles. Moving on to the next technique, that is chemical type.
Pressure of the water.
Sorry?
In AGM, how much pressure?
That is not, remember it is. You can check any textbook, you will find it.
If I want to carry 500 megapascal pressure,
yeah.
how can it take this?
500 megapascal.
Megapascal pressure of water.
You have to use pump.
Pump.
Yeah. If pumps आपको अगर प्रेशर क्रिएट करना है, that means you have to वाटर के प्रेशर हेड बनाना है. तो प्रेशर हेड कैसे जनरेट होता है फिर? और अदरवाइज ये कर सकते हैं कि पंप से हैं, पंप की स्पीड आ रहे हैं, आप कन्वर्जेंट नोजल यूज कर लीजिए. यू कैन यूज कन्वर्जेंट नोजल. सेंट्रीफ्यूगल पंप से भी हो सकते हैं. No problem with that. 500 megapascal is not a big deal. Okay, so you have to choose accordingly. You have to choose high power pump and you have to convergent the area. You have to just check that continuity equation A1 B1 is equal to A2 B2 and then you can do it. No problem with that. Okay. So next type, that is chemical type. In chemical machining, we used different type of corrosive reagent to corrode the workpiece surface selectively. Here, this is workpiece. This is deep in the chemical reagent, and a heating cooling coil is there to maintain the temperature. Okay, a agitator is there to move the metal debris from the workpiece zone. Okay. If you check the principle, then principle is that chemical machining is a controlled chemical dissolutions of the machine workpiece material by contact with a strong alkyl or acid solution. The special coating can be used, that is known as maskants. Maskants are used to protect the surface that which the metal is to not to be removed. Suppose this metal piece is there and we have to do machining selectively. We have to protect those areas by using maskants, which are not to be cut by corrosive action or chemical machining. And this method is widely used to produce MEMS or semiconductor industries. Moving on, this is electrochemical machining, and this process is based on Faraday's electrolysis principle. You can you remember that Faraday's electrolysis principle? Faraday's laws. No, that is two laws are there. One is for that amount of material removed by electrolysis is directly proportional to the quantity of current. Quantity of current means Q, that is I into T, ampere into time period. And next one is that the amount of material removal is proportional to its chemical equivalent weight. Okay, so this process is based on Faraday's laws of electrolysis principle, but just reverse process of electroplating. In electroplating, we used electroplating technique to provide a coat on the workpiece surface, and therefore we choose workpiece as cathode. But in case of electrochemical machining, we use workpiece as workpiece part is connected to the positive pole, and whilst tool part is connected to the negative pole. And then a gap is in between them. This is known as interelectrode gap or IG. This gap is required to prevent the short circuit. Okay. Now, as DC power supply is there, and this interelectrode gap is flooded with proper electrolyte, the electrolysis process start, and it will remove the metal from the workpiece surface. But this technique is also, or we can in research language we call this as copy paste technique, because we used to produce it workpiece. It can reproduce the shape of tool or structure of tool in the workpiece, and that way it is copy paste technique. So this is the principle of electrochemical machining. Now moving on, this is electro discharge machining. In here we used, the principle is that workpiece is there, electrode is there, it may be negative, maybe cathode, maybe positive. Here the workpiece may be positive, and tool this in case suppose for example in case of ECM that workpiece should be positive anode, but in case of EDM it is not necessary. It may be negative, may be positive. It depends on that fact that what do we need. If we need the maximum metal removal rate or MRR, then we go for that workpiece positive, tool negative. If we need tool wear rate, then if we need high tool wear rate, then we have to change the polarity or reverse the polarity. Now obviously question why tool wear rate is required, because tool wear rate not is essential for us, tool is not that beneficial for us. but we are presently using this technique, EDM technique, for coating purpose. Okay, we used modify this technique, EDM process, for electro discharge coating. In that process, what do? We just prepare a powder metallurgy tool. By powder metallurgy, green compact tool. Okay, titanium and copper, or tungsten and copper. Okay, now if we reverse the polarity, then what will happen? The tool wear rate will be high, and that tool wear, that is titanium or copper, is coming out from the tool, that will react with the dielectric. Normally in case of EDM, hydrocarbon oil like kerosene is used for as a dielectric. That will react with dielectric, and it produce a carbides, and that will produce a coat on the workpiece surface. So you use this technique to coat aluminum workpiece using aluminum workpiece by EDC process to get the coating of tungsten carbide or titanium carbide on aluminum, and thus the outcome, that coated part in outer surface, the wear resistance properties, corrosion resistance properties, and hardness is high. But in case of inner part, that is aluminum, that is soft and toughness is high. And this type of component is very much beneficial or very much useful for fatigue purpose, where fatigue loading is there. So if we establish a potential between anode and cathode, the electron will start move from the cathode towards anode. Okay, as it moves, it will impact the dielectric molecules and create a channel, of narrow channel of ionized molecules. And these ionized molecules, or these channels, can be seen as spark. And due to that spark, that heat will be generated, and due to that heat, the fusion and vaporization of metal will be done. And due to that, we can cut the material. So these are basic principle of this technique. And finally, WDM. WDM, the modification or extended version of EDM process. The difference is that here wire is used as tool, cutting tool. Rest of the principle is same. So this is all about different AMPs which are very much popular, presently popular in the industries or among researchers. So moving on. So till now it's okay, or any doubt? Okay. So these techniques, after Second World War, this AMP starts flourishing, and it is okay with 1970s and 1980s. But after 2 or 3 decades, we found that these processes are having defined limitations or drawbacks. Okay, for example, EDM and ECM. EDM and ECM is mainly limited to conducting material. If it is non-conducting material, we can't do, or we can't cut it using EDM or ECM process. Then corrosive chemical machining. For example, chemical machining, the material is removed by corrosive action of reagent, but some of the materials are inert basically, so we cannot cut those material using chemical machining. So these drawbacks needs the exploration of these drawbacks basically necessitates the exploration of hybrid machining processes. Now, what is hybrid machining processes? Hybrid machining processes are conceptualized by combining 2 or more than 2 AMPs or AMPs with conventional techniques. For what? To club the benefits of both the processes. Suppose one AMP is there, another AMP is there. It has its own benefits, So we have to club the benefits of both the process in such a way that it will just minimizes its drawback and it will minimizes its drawback. Okay, so this is the concept of hybrid machining process. Hybrid machining process basically a step ahead than advanced machining process to minimize its drawbacks of advanced machining processes. For example, if we just check the drawbacks of defined AMPs, we can say that, for example, ECM, electrochemical machining. What we will do? We use a cathode, we use an anode, a electrolyte supply is there. As a electrolyte, normally sodium chloride, that is salt solution, aqueous solution of salt is used as electrolyte. But if we supply the power, what will happen? That water of that electrolyte will also dissolute, and it will produce H plus and OH minus, and finally hydrogen and oxygen. That oxygen reacts with the workpiece surface and produces a oxides layer on the workpiece surface. But this oxides layer is basically non-conductive or insulating in nature, and therefore it stops the process further. So we have to remove that layer, otherwise we can do, or we can continue the ECM process. So this type of drawbacks are there for each and every AMPs, and these drawbacks can be minimized only by clubbing this 2 or 3 AMPs at a time, or clubbing these AMPs with conventional techniques. And these are nothing but hybrid machining processes. So hybrid machining processes are conceptualized by clubbing 2 or more AMPs and AMPs with conventional techniques. AMPs or AMPs plus conventional techniques. Okay. So on the basis of that, this is an example of hybrid machining processes. For example, this is example of electrochemical grinding. Okay, electrochemical machining is there, mechanical grinding is there. We club the electrochemical dissolution phase of electrochemical machining with mechanical abrasion phase, and thus we can solve our purpose. If we use only ECM, then what will happen? The same problem will be occur, that a insulating lattice or workpiece, and the process will be stopped. So first step is that we continue the ECM process. A insulating layer is formed on the workpiece. We use, then after that mechanical grinding comes into picture. It removes that by scrubbing or by abrasion. It removes that insulating layer, produce a fresh workpiece surface, and that fresh working surface is conductive in nature, and then ECM process continues. So the drawbacks can be minimized by clubbing both the process. So these hybrid machining processes are classified in mainly 2 groups. First group, in which both the constituents and processes are directly involved in material removal. For example, electrochemical grinding, already discussed in the last slide, that is. And the second one, in which one removes the metal from the workpiece, and other produce a favorable machining condition for the same. For example, ultrasonic assisted abrasive flow machining. Abrasive flow machining is a new term. It is not already discussed. It is not discussed now. So abrasive flow machining is that we used a viscous fluid or viscous material that is filled up with abrasives, that contains abrasive particles. As it moves through internal cylindrical surface or external cylindrical surface, it will create a fine finish on that surface. Okay, that is abrasive flow machining. Abrasives are moving with any viscous fluid or viscous material, and it will erode the surface and produce a fine finish surface. So ultrasonic assisted abrasive flow machining, we club ultrasonic technique with abrasive flow machining, and thus what it will do, that debris, that suppose this layer is there, okay, this external cylindrical surface is there, and we have to finish this surface. Viscous the abrasives with viscous fluids or viscous material is moving over here. Okay, what will happen? That abrasives erode this part, but metal debris are there. Then what will happen? So we have to provide any ultrasonic vibration or any vibration to remove that metal debris from the machining zone. Otherwise, that metal debris will act as cutter, and ultimately we will get a poor surface finish. So we have to just move that metal debris from the working zone, and that's why we club ultrasonic assistance with the abrasive flow machining. This is a complete list of hybrid machining processes. Those are available, or those are very much popular among researchers, or the research going in this field. Here H stands for honing, L stands for lapping. Any of the technique is not known to you, then you can ask me. This AFM, this is abrasive flow machining. This is electrochemical honing or electrochemical finishing. Ultrasonic assisted lapping. Basically, this honing and this is ECM. This combines with and produces this hybrid technique, that is electrochemical honing or electrochemical finishing. We will discuss this hybrid technique later on. This lapping club with this USM, ultrasonic machining, and produce ultrasonic assisted lapping. Similarly, this AFM club with this USM and produce ultrasonic assisted abrasive flow machining. This USM club with this EDM and produce EDMUS, ultrasonic assisted EDM, or ultrasonic assisted electric discharge machining. Then this ECM club with this USM technique and produce US ECM, that is ultrasonic assisted electrochemical machining. Okay. This ECM club with EDM and produce ECDM, electrochemical discharge machining. Similarly, ECM produced with EDM and similar grinding is there. Here, two AMPs are there and one conventional technique is there, and produce electrochemical discharge grinding. Finally, ECM club with grinding produce electrochemical grinding. EDM club with grinding, that is EDG, electric discharge grinding. And finally, this LBM is there, that is laser beam machining, the high amount of high power radiation used to cut the material of laser. So laser beam machining is club with ECM technique and produce ECML, that is laser assisted electrochemical machining. Similarly, LBM club with EDM and produce EDML, that is laser assisted electric discharge machining. So you will discuss these techniques one by one. This is the first technique, that is electrochemical dissolution and electrodischarge erosion. So what is the main drawback of electrochemical machining or electrodischarge machining? The main drawback is that in case of electrochemical machining or electrodischarge machining, the material should be conductive in nature. If it is non-conductive, we can't cut it using ECM or EDM. So if we go for glass, if we go for ceramics, then what will happen? So we have to club these two techniques at a time. Okay. In this process, what do we do? Suppose we have to cut or we have to drill one glass bead or a glass plate. Okay. So what do we do? We take a tank that is filled up of any alkali solution or basic acid solution, either NaOH or hydrogen sulfuric acid, H2SO4, and then we dip that glass plate inside that alkali or acid solution. Okay. Then we use a tool. Okay, that tool is copper tool. Okay, simply copper tool, copper rod or copper strip basically. Okay, so we connect power supply one pole to the copper, that is negative pole connected to the copper tool, and then that glass rod, that's the glass plate, is connected to the another pole. Okay, but this glass is deep in the electrolyte. Then this electrolyte will act as another cathode. This electrolyte will act as another electrode basically, and thus spark will be occurred, and due to that spark, the glass, this cutting operation will be done. If anyone just wish to carry your research purpose or any project work on this field, it is very easier to develop this setup in the lab or in your just in-house. You can develop it. So very easy setup, easily can be installed, or that it is also economical. No too much costly equipments are not required actually in this process. Just single thing is that one copper rod, I think 15 or 20 rupees cost. One glass plate, it is 5 to 10 rupees. One tank, you have to prepare that tank either by perspex or plastics, because you have to see that you have to see that process, either it is going on or not. So you have to tank, and then any acid or basic solution. So either NaOH or sulfuric acid, or you can use, if you add just green manufacturing into it, then you can use just citric acid, lemon. घर में जो नींबू होते हैं उसको भी आप यूज कर सकते हैं, एज अ न्यू जो लेमन जूस होता है, दैट कैन बी यूज्ड एज electrolyte for it. So this I'm coming that you need a variac with DC power supply, and that is only costly, and that I think it is not much more than 25,000. Using this, one thing is there, that is setup, or that is a support for that, and you can use any drill machine or milling machine, vertical milling machine or drill machine, vertical drill machine for this purpose. Okay, so if drill machines or milling machines are available in any workshop and any lab. Okay, so just you have to choose, you have to purchase one voltage supply or variac. You have to choose, you have to purchase one copper rod, one glass plate, and you have to prepare a tank. that is costly, that is near about 1000 200 rupees, and thus you can produce this setup in-house and below 50,000 rupees. You can complete a complete study below 50,000 rupees. And you would go for just if you go for purchasing any advanced machining process equipment or any advanced machining process setup, then it costs near about, in market is cost near about 15 to 20 lakh. Recently in NIT Kurukshetra, one faculty is there, he purchased one ultrasonic drilling machine, and it came from USA, and it cost near about 75 lakh. So that is, sorry?
That was purchased in laboratory lab.
That is for lab. That is for lab only. Purchased by from TechUp fund. But 75, you are not going to produce a sellable product. Then why 75 lakh? You can develop that setup within 2 to 5 lakh. Then why 75 lakh is you are going to consume? Okay. So that is another aspect of the study, that try to develop all the setup in-house. It is useful or beneficial for all the people, beneficial for government, beneficial for your fellow students or fellow researchers, beneficial for you also, because you can know that all the ups and downs and all the hindrance, all the hurdles to create or to fabricate a setup, and you can manipulate it or you can modify this setup for other purpose. Presently, I am suppose working to develop a setup or develop a tooling for lathe. Okay, honing tool for lathe. Okay, and we will just a BTech project is, this is for BTech project basically. We use a honing tool for lathe. We can just, if we use this, we will club with the tool post. Okay, if purpose is solved, then we just remove from the tool post. Okay, similarly, it is our we want to that add some power supply with this honing tool, and we can use it as for electrochemical honing or electrochemical discharging for EDM or ECM purpose. Okay, so this is our this is basically proposed work. We are working on it. So moving on to the next process, that is abrasive electro discharge grinding, that is AEDG, or in this process mechanical abrasion curbs with electro discharge erosion. Okay, so in case of electro discharge erosion, the electro discharge erosion is the concept is same for EDM process, nothing else. Okay, but we have to change the sparks. The sparks is generated in the closest point between cathode and anode in case of EDM, but we have to change that spark. If spark is occurred in the same position, then we will get a drill. We will not get a fine finish or fine surface, and therefore we use a grinding wheel. Okay, and thus we can get a final product. This is electrochemical discharge grinding, electrochemical dissolution, mechanical abrasion, and electro discharge erosion. Already electrochemical dissolutions which club with electro discharge erosion, that form electrochemical discharge machining. Okay, that is used to cut non-conductive metal. For example, that lemon juice, and this example is for that. But the drawback of that process is that electrochemical process is going on, so there is chances of producing a passivation layer or insulating layer. But we have to remove that insulating layer, and therefore another part is added, that is mechanical abrasion. We use a grinding wheel here, and thus we remove that layer to complete or to continue the process. This is ultrasonic vibration with mechanical abrasion. This is an example of ultrasonic assisted lapping. Lapping is a finishing process mainly for mating, used for mating surfaces. Within a two mating surface, abrasives are there in a oil or viscous fluid, and as it moves, a relative velocity or relative movement is there, it will finish the surface or it will improve the mating condition of the surfaces. So here we add ultrasonic vibration or ultrasonic assistance with this lapping. Thus we can improve the finishing process or improve the surface finishing, surface finishing, and we can easily remove the metal debris from the machining zone. Okay. Now coming to the next process, that is ultrasonic vibration and electrochemical dissolution. This ultrasonic here electrochemical dissolution is there, and the same problem is there. The metal debris can create problem for the final finishing, and we have to remove that metal debris, and therefore we club ultrasonic assistance with this technique, and it produces ultrasonic assisted electrochemical dissolution. The same problem is there to remove the metal debris that will produced by EDS process, electro discharge machining process, by ultrasonic vibration, and therefore ultrasonic vibration is grouped to either clubbed with electro discharge erosion and produce electro ultrasonic assisted electric discharge machining. This is laser ablation or electrochemical dissolutions. Yeah, laser technique, laser methods is lasers is used, or laser technique is used to accelerate or to enhance the qualities of electrochemical processes.
इसमें लेजर जब डायरेक्ट फ्लूइड में मूव करेगा उसकी वजह से
लेजर की वेलोसिटी कम हो जाएगी
जब वो उसमें चलता है जब आदमी वैक्यूम में चलता है।
लेजर मीडिया पे डिपेंड करता है उसका वेलोसिटी, रेडिएशन के मीडिया पे डिपेंड करता है क्या? मीडिया पे डिपेंड नहीं करता।
एक और सर जब अभी आपने उसके पीछे
हाँ
और एक और ये जैसे
ये
जो ग्राइंडिंग कर रहे हैं सर,
हाँ
एक तो इलेक्ट्रोकेमिकल है,
हाँ
तो कांटेक्ट नहीं हो रहा। हम जो ग्राइंडिंग करेंगे तो उसके कांटेक्ट में आधा एक्यूरेसी
नहीं। एक्चुअली क्या है कि हम क्या करते हैं, कोटिंग जब ग्राइंडिंग व्हील बनाते हैं वो पर्पसली बनाते हैं, हम उसे प्रिपेयर करते हैं। उसमें क्या है कि सपोज ग्राइंडिंग व्हील है, और ग्राइंडिंग व्हील का जो फेस है, सपोज ये मान लीजिए कि उसका थिकनेस है ग्राइंडिंग व्हील का। ओके, ग्राइंडिंग व्हील ऐसे है, ये ग्राइंडिंग व्हील मान लीजिए, ठीक है, ये उसका थिकनेस है, चौड़ाई है। ओके, अब ये जो दो लेयर हैं, इस दो लेयर को कॉन्डक्टिव कर दीजिए, एक को एब्रेसिव कोट कर दीजिए, ठीक है। अभी जो एब्रेसिव कोट है क्या करते हैं, हम कैसे बनाते, कैसे उसको पहले कॉन्डक्टिव मटेरियल का ड्रिल बना, कॉन्डक्टिव मटेरियल का ग्राइंडिंग व्हील बना लिए, उसके ऊपर क्या किए, उसके ऊपर एक लेयर पे कोटिंग चढ़ा दिया हमने। जैसे कोटिंग चढ़ेगा वो एक 150 माइक्रोन या 200 माइक्रोन का एक थिकनेस इसका बढ़ जाएगा। अब जब ये कांटेक्ट में आएगा, ओनली एब्रेसिव कोटेड पार्ट विल कम इनटू कांटेक्ट, कॉन्डक्टिव पार्ट कभी कांटेक्ट में नहीं आएगा। तो कॉन्डक्टिव पार्ट जो है वो इलेक्ट्रो डिस्चार्ज मशीनिंग एंड इलेक्ट्रोकेमिकल मशीनिंग के लिए यूज होगा। जो एब्रेसिव कोटेड पार्ट है जिसका थिकनेस ज्यादा है, वो पार्ट हम यूज करेंगे ग्राइंडिंग के लिए। ये टेक्निक है। क्लियर और कुछ कॉन्फ्यूजन इज देयर? नहीं, कुछ कॉन्फ्यूजन है पूछ सकते हैं, ऐसा कुछ नहीं है। क्लियर नहीं, आई थिंक ओके। हाँ, वीडियो क्लिप तो नहीं है बिल्कुल कोटिंग का। नॉर्मली जो वीडियो क्लिप है वो ECH बेस्ड है, तो आई विल शो इट लेटर ऑन। सपोज दिस पार्ट इज देयर, ओके, ये कांटेक्ट में आ रहा है, ओके, इसके ऊपर हम एक छोटा सा कोटिंग कर दिए, ओके, कोटिंग कर दिए। ये पार्ट है, सपोज सेंट्रल सिलिंड्रिकल पार्ट है, दैट इज ये जो छोटा वाला थिकनेस है, ओके। एंड नेक्स्ट जो पार्ट है, जो कोट पार्ट है, वो ये है। थोड़ा सा थिकनेस ज्यादा हुआ, कोटिंग कर रहे हैं, किसी के ऊपर कोटिंग हम 100 माइक्रोन या 200 माइक्रोन का कोटिंग कर रहे हैं, तो वो उसका थिकनेस ऑब्वियसली बढ़ जाएगा, जो आउटर डायमीटर है वो बढ़ जाएगा। अब अगर हम इसको सैंपल को टच करा रहे हैं, तो कौन से पार्ट टच में आएगा, कोटेड पार्ट और अनकोटेड पार्ट? कोटेड पार्ट टच में आएगा। दैट कोटेड पार्ट इज एब्रेसिव, मेड ऑफ एब्रेसिव। एब्रेसिव्स आर नॉन कंडक्टिव इन नेचर जनरली, ओके। सो वो जो नॉन कंडक्टिव एब्रेसिव्स हैं, दैट विल एक्ट एज ग्राइंडर, ओके। And this uncoated part that is metallic in nature, that will act as electrode for electrochemical machining or electro discharge machining. The principle is almost same for electrochemical honing. We will discuss electrochemical honing in detail later on, so that time you will understand all the things, what actually is going on.
मैं ले रहा हूँ सर, जो कांटेक्ट में आ जाएगा,
हाँ,
एक्यूरेसी होता है अनकन्वेंशनल मशीन पर, टूल कांटेक्ट में रहेगा वर्कपीस, एक्यूरेसी तो कम हो जाएगी।
accuracy तब कम होता कि अगर हम ये this grinding technique is used for remove the metal, then it will happen. But this grinding technique is purposely used to remove the insulating layer. If we check the ECH process, ECDG process, ECDM process, any hybrid process which combines electrochemical machining or mechanical abrasion, we can observe that the 10%, 5 to 10% of the material is removed by grinding or mechanical abrasion, and rest of the part, that is 90% of the material removal is done by electrochemical machining or electrodischarge machining. So major contribution from advanced machining process type, not from conventional techniques. That's why that our final outcome, that is surface finish, is good.
The side view part of the channel side view there also
These drawing are done by me only for this presentation purpose. Okay, we can just, I can collect it from the other sites, but it is not actually legal, or you have to acknowledge them for that, or I have to take prior permission from that. So this is recent problem, plagiarism and copyright problems are there. So you have to try to avoid it. Yes. Okay, sir. So the still now, so main highlights are that AMPs and conventional machining. The main difference between AMPs and conventional machining. Now, what is hybrid machining processes? It is, I think it is clear. Then necessity of hybrid machining processes. Why it is required basically. Why AMPs are there, conventional techniques are there, then why hybrid machining process? So this is, I think, clear. And defined, we already check defined hybrid machining processes, their constituent processes, their benefits, and which type of drawbacks can be minimized by this technique. Okay. So I think we'll go for a break, and then after we'll start in detail of the detailed discussion of ECH technique. So till now we discuss about machining, advanced machining, hybrid machining techniques. Now we move on, and this is one type of hybrid machining process, that is electrochemical honing. So this is electrochemical based hybrid machining technique. In case of ECH or electrochemical honing, we combine strict cross-hatch lab pattern, residual stress induced surface, ability to correct microgeometrical or macrogeometrical errors. Okay. So what is electrochemical machining? We will discuss that constituents one by one. While first one, that is electrochemical machining, is already discussed. That is the advanced machining process and reverse process of electroplating. This is tool is there that is connected with the negative pole. Workpiece is there that is connected with the positive pole. This workpiece is dipped in electrolyte. A gap in between them, workpiece and tool, that is interelectrode gap, and this interelectrode gap is flooded with proper electrolyte to continue complete the electric circuits, and thus we can continue the process. So if we choose iron as workpiece material and copper as tool or cathode, and aqueous solution of NaCl, also salts, normal salt, as electrolyte, then these equations will be happened. It will start with the dissolution of H2O and NaCl, and it will ends with generation of H2 gas, hydrogen gas, and precipitation of ferric hydroxide. So we don't need to go details in the reactions. These are chemical part. So moving on. So basically the advantage, applications, and advantage and application of electrochemical machining are: in ECM, electrolyte removes dissolution products, metal hydroxide, heat, gas bubbles generated in the electrode gap, and thus it can improve the surface finish of the process or process performance of this technique. It can produce complex cavities in high strength materials and produce bar-free surface. In case of ECM, the benefit is that the limitation is that the material should be conductive, but benefit is that material hardness, which is a limitation for conventional machining, but here it is not a limitation. We can cut titanium also, we can cut stainless steel also, we can cut tungsten also by electrochemical machining, provided that the material should be conductive. Hardness is not a limiting factor for ECM process. So this is the beauty of main beauty of this process, this technique. So this material is removed in case of ECM and atomic scale, and therefore obviously good surface finish we will get after final operations. Various industrial techniques have been developed on the basis of electrochemical machining process, and some of them are listed here. For example, electrochemical drilling. Here electrochemical technique or electrochemical dissolution process is used to drill the holes. Then electrochemical jet drilling. This process is used a electroconductive jet of electrolyte is used to cut a workpiece or to drill a workpiece material. We also studied this technique, this electrochemical jet drilling, during my staying in IIT Roorkee. We prepared a setup for electrochemical jet drilling, okay, and we used pump to just supply the electrolyte, and with nozzle we fix a platinum wire or titanium wire, okay. As this titanium wire is connected to the negative pole of the supply, and on the other hand a workpiece is there. We choose that time we choose inconel as workpiece material, that is super alloy is there, and producing a through hole is really difficult in case of incolloy or inconel. But using this electrolytic jet drilling, we can easily produce holes in super alloys, and that aspect ratio of that gap. Aspect ratio means length by depth. That ratio ranges up to 80, 10 to 80. Okay, is I think the big number 80s. So we used one titanium wire, and that electrolyte jet as moves over it. That electrolyte jet turns into conductive in nature, and that conductive jet do the cutting operation finally. Okay. And for this is electrochemical hole deburring. Sorry, any question? Hole deburring, and these are typical examples of that ECM components produced by ECM or finished by ECM products. Now coming to the next constituents, that is honing. Honing is basically a subtractive type manufacturing process in which material is removed by cutting action of abrasive gains. But it is secondary process and generally carried out after grinding operations. So it is used to improve the form, dimensional precision and surface quality of a workpiece under constant surface contact with the tool. So there are lots of honing techniques, 8 or 9 type of techniques are available in industry and among researchers, but 3 of them are listed here. For example, long stroke honing, that is also known as honing. Then soft stroke honing, that is also known as fine polishing or fine finishing. And finally, gear honing, that is used to finish the gears. So long stroke honing is used for connecting rod holes, finishing connecting rod holes, breakdowns or cylinder liners. This is the typical diagram of long stroke honing or honing. Then soft stroke honing, it is used to crankshaft or rotor shaft. This is a typical diagram of soft stroke honing. This is honing stick or honing tool. This is workpiece, it rotates and it translates. So it is a simultaneous rotating and reciprocating motions is there, and due to that we'll get a cross hatch lay pattern, that X type hatch pattern in the final object or final outcome surface. Okay. This is for outer external cylinder, obviously. This is for internal cylinders. Okay. This is for external cylinders, and this honing, gear honing, that is used for gears to produce or to improve the quality of flank surface of gear. Okay. So now coming to that hybrid technique, that is hybrid electrochemical honing process, which combines electrochemical machining and honing. It is more faster than electrochemical machining and honing. Okay. Its surface finish achieved by electrochemical honing is obviously better than both the techniques. Okay. And this technique can be used. This technique can be used for cylinders also, to finish cylinders, whether it is external cylinders or whether it is internal cylinders or gears. We can use it for providing good surface finish to the gears. Now coming to the details. This is a schematic diagram that explaining the basic process principle of the technique. Here ECH, ECM and honing, electrochemical dissolution fail.
Yes, sir.
So please slide on.
So this is ECH process, combines two process, electrochemical machining and honing. Uh, Electrochemical dissolution phase combines with mechanical embryo phase, and we will finally easily cut the workpiece or finish the workpiece product. If we check this diagram, step 1, step 2, step 3 and step 4, we can find the actually what is going in between this process. That's cathode is there. Okay, this cathode part is used as tool. Workpiece is there, that part is used as workpiece is normally connected to the positive pole and used as anode, and in between them electrolyte is there. At initial condition, step 1, at initial condition, the asperities or peaks and troughs of the surface is more. Okay, now as the power supply is connected to the both the cathode and anode, what will happen? The electric circuit completes, and due to that electrolysis process will start. So after step 1, we'll get a reduced value of peaks and valleys. Okay, but the problem is that in case of electrochemical machining, that aqua solution is there, electrolyte, aqua solution by NaCl is used as electrolyte, and therefore this aqua solution, dissolutions of this aqua solution will produce oxygen. That oxygen reacts with the metal oxide microfilm, that react with the workpiece and produce metal oxide microfilms. That films acts as insulator or passivation layer. This layer is a passivation layer, and this is insulating in nature, and thus it will, what will happen? It will stop the ECN process, as this workpiece is now not now conductive in nature. Now it is insulating. So we have to replace, or you have to move this part, move this layer, or you have to reduce this part, or you have to remove these things, these layers from this workpiece surface. Here comes into honing comes into picture. So honing is basically a different honing tools, that is form of abrasives that crafts this work surface and removes that passivation layer from the workpiece surface and produces fresh surface. Fresh surfaces. As a result, what will happen? Finally, we get a finished product. The beauty of this technique is that initially these are peaks and these are valleys. Okay. When we start the ECM process selectively reduce the peaks, and same case for honing. During honing, only peaks will come into contact and the peaks will be removed. As a result, after some time, we will get the RZ value, the maximum depth and peak and valley height, difference between peak and valley, will lower RZ value. Okay. So this is the process principle or basic mechanism of a material removal of ECH process. So this technique mainly used to produce, mainly used to finish either cylindrical surfaces or gears. Cylindrical surfaces is both, either it may be external, it may be internal. So this is for internal cylindrical surfaces. Okay. So this diagram showing the ECH of cylinders, and this technique is used to finish the internal cylindrical surfaces. This is the workpiece surface. This is honing tool. Okay. These are honing sticks, and a rotating and reciprocating motion is provided to the honing tool. This is their pump is there to flow to supply the electrolyte at the machining zone. Okay. Now this workpiece is connected to the positive pole, tool is connected to the negative pole. As pump supplies the electrolyte in between them, the workpiece and tool, ECM process start, and this process going on. But after a few time, as it is already discussed, the insulating layer is there. This abrasive sticks, your honing sticks, remove that layer and produce fresh metal for further electrochemical dissolutions. So this is for cylinders. This is the broad view of honing tool used for electrochemical honing for cylindrical surfaces. This electrolyte passage, honing sticks are there, and this is workpiece material. So the principle for electrochemical honing for cylinders and for gears all are identical, but difference is that only the design of tooling, how to fabricate the tooling part. Okay, the difference is, main difference is tooling part. Rest of the parts, that is power supply system, electrolyte supply systems, and fixtures and setups, all are same. The difference, main difference is that tooling. The tooling is completely defined for cylinders, for gears, completely different. So you all know that gears are very vital element. Actually, this is the motive to continue this process for gear or to finish the gears. Gears are very vital element for mechanical industry. This all know, and it is used to transmit power and motion from one shaft to another. If it is parallel shafts, then either spar or helical. If it is inclined, sorry, not it is not parallel, not intersecting, then worm. If it is intersecting, then bevel gear. Okay, so it is observed that annually 2 to 3 billion euros are consumed for gears. Okay, and this amount is large. So we can reduce this amount either by finishing the gears which are already used. Gears are once used, we just throw it. But if we can by finishing by ECH process, we can reuse it. So we can thus reduce the cost, that 2 to 3 billion amount of money. So therefore we can try this technique for gear finishing process, and for that we develop a setup, experimental setup, or fabricate experimental setup in house. And so these are basically history of process. This is the principle for gears. Principle is same. The difference is that there is that for that only that tooling design is different for cylinders and gears. Here what will happen? First look at this picture. This is workpiece gear, the center one. The left one is cathode gear, and this one is honing gear. Okay, so a gap in between them, this workpiece gear and cathode gear. If you look, this cathode gear, it is specially designed. This is insulating gear, this is insulating gear, in between them a conducting gear is there. So this cathode gear is specially designed by clubbing, by sandwiching a conducting gear between two insulating gear and undercutting the profile of conducting gear, then insulating gear. As a result, the outer diameter of conducting part is lower than the insulating part. This is the answer for your last question actually. Yeah. So normally this undercut is up to 0.25 mm to 0.5 mm. Okay. Now, so when this workpiece gear rotates, the only insulating part will come into contact with the cathode gear, not the conductive part. Now, as this inter-electrode gap, the undercut, is flooded with proper electrolyte, the electric circuit completes and ECM action starts. Okay. Rest of the process is same for electrochemical honing for cylinders. The same principle, electrochemical honing, same generation of oxygen, evolved oxygen due to ECM, generation of microoxide layers, insulating layers on a workpiece surface, then scrubbing action of honing gear to remove that layer and producing the face metal for further ECM dissolutions, and we will get the final product. So these are defined process parameters. Those are basically influence the outcome of ECS process performance. Those parameters are classified in mainly 4 groups: power supply related, electric supply related, honing related, and workpiece related. Power supply related are current, pulse of time, pulse on time, duty cycle, and voltage. Electrolyte is composition, concentration, pressure, temperature, flow rate, conductivity, and pH. Type of abrasives: for honing, abrasive particle size, rotating and reciprocating speed. In case of workpiece, is size of workpiece, electrolyte and mechanical properties of workpiece, and pH. The current ranges from 10 to 30 ampere. In case of ECM, we used high amount of current. Okay, but in case of ECH, that we add that honing part, that why that current range here is lower. The current value of current is lower, that is 10 to 30 ampere. Okay, This pulse on time and pulse on time. Pulse of time varies 1 millisecond to 1 millisecond to 5 millisecond, while pulse on time varies from 1 to 2 millisecond. This duty cycle is accordingly. Duty cycle is equal to on by total time. Okay. Voltage ranges from 10 to 40 volt. Okay. And these data is observed according to the experimental observation. I'm telling the experimental observations. Okay. Then electrolyte compositions. Normally we used sodium chloride. Sodium chloride, basically this is economical one and easily available. We can easily we go to market and take it on 10 rupees kilo. So most easiest electrolyte. You can easily form this electrolyte by mixing this salt with water. Okay. This composition, we can change composition. If we mix 2 or 3 salts to get better effect or to get better improvement or enhancement. Okay. Or other we can use other glycerols and other hydrocarbons to improve its performance. Okay. Next part is concentration. This concentration is varies up to 1% to 10%. Okay. If we increase the concentration, what will happen? That salt will then start its corrosive actions. Okay. It will also corrode the workpiece. So we stop that part up to 10% concentration. Then pressure. That pressure part. This is normally kept at 1 megapascal. Okay. Then temperature. Temperature is that if we increase the temperature, what will happen? The conductivity depends on the temperature of the electrolyte. Okay. If we increase the temperature, what will happen? The conductivity will be increased. The main focus is that ECM process based on electrolyte, mainly based on electrolyte. If conductivity increases, what will happen? The ECM action or the rate of ECM process will accelerate. But there is a limitation. If we go beyond 40 degrees centigrade, we start from the 20 degrees centigrade, that is 20 or 25 degrees centigrade, that is room temperature, and moving on. If we go beyond 40 or 45 degrees centigrade, what will happen? The chances of hydrogen evolution will be increased due to different chemical reaction, and that evolvement of hydrogen gas reduces the surface finish. Okay, and therefore we stop the temperature or working temperature of electrolyte at 45 degrees centigrade. Then flow rate, conductivity, pH. pH depends on the whether this electrolyte is basic electrolyte or acidic electrolyte. So pH is not a matter of discussion. If we go for acidic, then it is above 7. If it is then acid, then below 7. Then type of abrasives. Type of abrasive is a major focus. Okay, because different abrasives, if it is we are going to use aluminum oxide, the abrasion capability is different than silicon carbide. Okay, so type of abrasive is a major concern, part of major concern. Then abrasive particle size, because if we use small particles, the surface finish will be better surface will be good. So say abrasive particle size is also a influencing parameter. Then rotating and reciprocating speed, because this is the relative motion which will cover the complete profile as well as accelerate the or complete the honing action basically. So this is also an influencing parameter. And then workpiece related parameter, size of workpiece. Size of workpiece not size of workpiece not influence the process performance basic, but it influence the design of the setup. If we go for larger size workpiece, we have to we must have that much of capability in the setup so that we can accommodate it. Okay, so there will be, if we in the later side I will show some of the peaks of the setup and then I will discuss it. So these are some of the literature review carried out by researchers. It started in 1967 or 68, but that part is mainly for ECH of cylinders. The ECH of gears was initiated in 1979, that is Capello and Bartoglio, and after that 1981 Chell et al. Accelerated this study. Then Bajinsky, Kretev, We et al., He et al., Y et al. This Mr. 2009, this is my work, or this is my study. And then after that Singh continued this part, this is in 2010, and Jerry Porter 2011. This is going on, this work is going on, and I think 20 or 25 papers already added in this list from 2011 to 2015. So now coming to the experiment setup, test limit develop. in the Department of Mechanical Engineering, IIT Roorkee. So this is the schematic diagram of the setup that has been developed. Okay, this is for ECH of gears, but mainly for spark gears. So this is tool. Sorry, this is workpiece gear. Okay, and this part is tool. Okay, a rack and pinion service. Rack and pinion is there. If we this workpiece gear, okay, this honing gear, this is copper gear and honing gear. As already discussed, that conductive gear is clamped or sandwiched in between two non-conductive gear. Undercut, the outer diameter of conducting gear is lower than the outer diameter of honing gear. Thus, this honing gear only comes into contact with the workpiece gear. Now, this a rotating and reciprocating motion is supplied to the workpiece gear. Then, this will act as driver, and this gear will act as driven. Okay. We need rotating and reciprocating motion so that we can finish the complete profile. Okay, complete profile in this way and in this way, both the way. Okay, so the rest of the principle is same. Power supply unit is there, and electrolyte supply unit is there. On the electrolyte supply unit, we will flooded this part, ECM action start, and honing will do the scrubbing action, and we will get the final product. Another arrangement is that is rack and pinion. This is, suppose this workpiece gear is of outer diameter of 5 inch, then this diagram is okay. But after a few times, we need a gear of 10-inch diameter. We have to finish a gear that is having diameter of 10 inch. And what will happen? We have to move this part. Okay, that way rack and pinion is there to accommodate different sizes of gear. But problem is that the pitch should be, so the diametral pitch should be same. If diametral pitch basically, I think you know that what is diametral pitch. Diametral pitch, the physical significance is that number of teeth per inch pitch cycle diameter. It's reverse. It is FPS unit. If it is metric unit, then it is module. Amount of pitch circle diameter for one teeth. Okay. So if pitch is same, we can accommodate any size of gear. So this is the commercialization of this setup basically. This is a diagram that has been developed for bevel gear. Rest of the part is same. Only difference is that tooling part. Okay. In case of helical gear or in case of spark gear, we can provide rotating motion. Rotating motion is okay, no problem. But reciprocating motion is problem for bevel gear. We cannot provide reciprocating motion to the bevel gear, and therefore we have to, if we wish to cut the complete profile, if we wish to finish the complete profile, we have to do this type of arrangement. In here, this conductive part, here this cathode, both are tooling. Both tool are there. Both are tool. So in this tool, we produce this part by clubbing the conductive gear with non-conductive gear and undercutting the profile of conductive gear. But here conductive gear is at bottom portion. Okay. But in case of this part, that conductive gear is at upper portion. Okay, or front portion. Clear? So in this using this tool, we can finish this part only. Okay, using this tool, we can finish this part. In this part, this zone, ECH action will occur. In this zone, ECH action occur, and thus we can complete the profile, or we can continue the ECH process for complete profile.
टूल को मोशन नहीं देते हैं.
इसमें टूल को मोशन सिर्फ रोटेटिंग मोशन देते हैं. We cannot provide reciprocating motion for bevel gears ना. किसमें? वर्कपीस में रोटेटिंग मोशन है. वर्कपीस से रोटेशन मोशन है. बट ये जो हम लास्ट साइड में यहाँ पे रेसिप्रोकेटिंग मोशन भी प्रोवाइड कर रहे थे, वो हम बेवल गियर के लिए प्रोवाइड नहीं कर सकते.
यहाँ पे इस एंगल पे हम दे दें
किसको? रेसिप्रोकेशन मोशन एंगल पे दे सकते हैं, बट उसके लिए बेवल गियर है और साथ में रोटेटिंग मोशन भी हो रहा है, तो हमें अलग से उसको डिजाइन करना पड़ेगा, क्योंकि वो रिजल्टिंग ऐसे नहीं कि हम एक मोशन दे रहे हैं, अगर एक्सिस थोड़ा सा भी चेंज होगा तो वो एक्चुअली रिजल्टिंग वो पैराबोलिकल स्ट्रक्चर आएगा, वो चीज हमें कैम डिजाइन करके बनाना पड़ेगा। तो फिर हम उस सिस्टम को बाल्की कर रहे हैं, हम कर सकते हैं वो चीज, दैट कैन बी डन, दैट कैन बी पॉसिबल, बट हम जो अभी जो सेटअप है ये बेसिकली इजीएस्ट वे है टू कंप्लीट द स्टडी। हम उसको डिजाइन कर सकते हैं, बट एक्चुअली रोटेटिंग हो रहा है, साथ में इस डायरेक्शन में मूवमेंट देना है, तो हमें क्या करना पड़ेगा, उसके जो रिजल्टिंग मोशन है उसको कैलकुलेट करना पड़ेगा, रिजल्टिंग मोशन क्या होगा। क्योंकि जब रोटेटिंग और रेसिप्रोकेटिंग हो रहा है, ये रोटेट कर रहा है, रेसिप्रोकेट कर रहा है, इसमें कोई प्रॉब्लम नहीं, स्ट्रेट लाइन मोशन है, एक इस डायरेक्शन में मोशन हो रहा है, एक इस डायरेक्शन में मोशन है। बट जब एक तो इस डायरेक्शन में मोशन हो रहा है और एक इंक्लाइंड है, तो दोनों का जो रिजल्टिंग मोशन है वो हमें निकालना पड़ेगा।
But in case of barrel gear, there is a restriction of the size of the gear. This type इसके अंदर फिर restriction हो जाएगी।
नहीं, रेस्ट्रिक्शन नहीं है, वो चीज मैं डिस्कस करता हूँ। In this setup, 2 slots are there. This is the basically a table, okay, slide way. 2 slots are there. We can just move this part, and tighten that part. Okay, adjustment is there. This is possible. So thus we can accommodate different sizes of gear. But that is limitation is that pitch should be same.
Modular system.
Basically modular tooling system. So we can if we go for market value, want market value, then we have to commercialize. If we design it for a single size gear, then no one going to purchase it. This is a developed setup, photographic view of the developed setup.
लैब का है सर आपके यहाँ?
ये लैब का है जो सेटअप डेवलप किए थे, हमने फैब्रिकेट किए थे। This setup contains all the devices which we study in the mechanical classroom. All the devices, pump is there, heating cooling arrangement is there, power supply unit is there, DC motor is there to provide rotational motion. So this is pump and everything, pumps and piping to supply the electrolyte. Okay, this is heating cooling coil to maintain the temperature. Okay, if you are doing our experiment in the winter season, the temperature, there is a variation in temperature. We will start experiment at 30 degrees centigrade, and after that, after a few minutes, we will get that temperature is 20 degree. Then it will actually create problem for the outcome. So we have to maintain the temperature of electrolyte, and therefore we attach a high temperature में turbulence create हाई टेम्परेचर में टर्बुलेंस के मतलब कितने वो तभी होगा ना, टेम्परेचर अगर बॉइलिंग टेम्परेचर के आसपास जाए ना, तो मुझे नहीं लगता कि इंक्रीज होने के लिए कुछ टर्बुलेंस क्रिएट होगा।
रिएक्शन में,
हाँ,
रिएक्शन में कोई टर्बुलेंस अगर टेम्परेचर बढ़ जाए तो
हम अभी तक जो स्टडी किया दैट इज अप टू 45 डिग्री। सो 45 डिग्री में टर्बुलेंस का कुछ मतलब इफेक्ट नहीं देखे हैं, वो चीज ऑब्जर्व नहीं किए हैं। अगर हम फर्दर जाते हैं, हमें फर्दर जा नहीं सकते क्योंकि हाइड्रोजन इवॉल्वमेंट का प्रॉब्लम है, दैट विल क्रिएट पुअर सरफेस फिनिश, वो एक इफेक्ट है। तो उसने हमें स्टॉप कर रखे हैं कि हम 45 से ऊपर नहीं जा सकते। बट अगर हम फर्दर जाए तो शायद हम ये चीज़ ऑब्जर्व कर सकते हैं। बहुत सारी चीज़ है जो चीज़ हम स्टडी नहीं कर पाए हैं अभी तक, क्योंकि वो फैसिलिटीज़ भी हमारे पास तब नहीं थे, या वो फैसिलिटीज़ का जो आफ्टर इफेक्ट है या इम्पैक्ट है दैट इज़ नॉट सिग्निफिकेंट दैट मच। तो हम उस चीज़ को बेसिकली इग्नोर कर दिए कि हाँ इसे इग्नोर कर सकते हैं। जो चीज़ हम बेसिकली कोई भी रिसर्च अगर हम कर रहे हैं तो रिसर्च का मेन फोकस वही होता है कि हमारे पास जो फैसिलिटीज़ है, अवेलेबल फैसिलिटीज़ है, उसको लेकर मूव करना। ठीक है, अब मैं 2 करोड़ का मशीन खरीद लिए, फिर उसमें एक्सपेरिमेंट कर दिए, ठीक है, दैट इज ऑल्सो रिसर्च। बट उससे रिसर्च वो बेटर है कि कोई भी चीज़ जो हमारे पास अवेलेबल है उससे हम कुछ मॉडिफाई करके नई चीज़ बनाएं, नया टेक्निक लगा के, नया आइडिया लगा के, दैट इज मोर बेनिफिशियल फॉर दैट। क्योंकि 2 करोड़ का एक मशीन खरीदे, उसमें मशीन इक्विपमेंट या वर्कपीस लगा दिए, और वर्कपीस लगाने के बाद मशीनिंग हो रहा है, तो फिर हमने क्या किए एज ए रिसर्चर? हमारा कॉन्ट्रीब्यूशन क्या है? 0। वो तो मशीन ने किया सब कुछ। तो ये ऑप्शन, सेकंड ऑप्शन ने किया कि 2 करोड़ का मशीन हम खरीद रहे, 2 और 3 करोड़ का, देन वी कांट मॉडिफाई इट। हम कभी उसे मैनिपुलेट नहीं कर सकते हैं, क्योंकि कंपनी का एक वारंटी पीरियड है, उसमें प्रॉब्लम होगा। जो एक्चुअली जहाँ पे ये मशीन्स हैं जो उसके मेंटेनेंस के लिए है, वो प्रिवेंट करेगा, नहीं इसे करने की जरूरत नहीं है, मैनिपुलेट करो मत करो या मॉडिफाई मत करो। इससे अच्छा कि एक सेटअप बनाओ, फिर जितने मन चाहे मॉडिफाई करो, और जितने मन चाहे मैसेज उसमें डिफरेंट टेक्निक्स को, डिफरेंट आइडियाज को इनकॉर्पोरेट कर सकते हो. This is two basically two tanks are there, one here and another is here. This tank is reservoir and this is settling tank. Okay, reservoir is used to store the electrolyte, and from here it will this electrolyte will pump to the machining zone. Okay, machining done, then what will happen? By discharging pipes, that electrolyte, after machining, electrolyte with metal debris will collect in this tank. Okay, here this part and another this part, two magnetic filters are there, magnetic filters. Metal debris will, we can collect the metal debris from here, and we can further study that metal debris. What is the parameters of this thing, what is the process of what is the process performance of this thing, what is the characteristic of the metal debris. One more thing, that metal debris are in terms of atomic scale, because ion displacement is going on, so that metal debris can be used for abrasives also. If we're going to process this, or if we're going to use these things for other studies, so we can collect this metal debris from here and then we can use it for other purpose or other applications. This is the tooling system for spar gears. This white part is coated, basically coating, aluminum oxide coating. Okay, this is copper plate. This workpiece of AISI 1040, just mild steel. Copper and brass systems is there to supply power. Rack and pinion arrangement is there to move this bracket from one end to another end, so that we can accommodate the different sizes. This is the machining chamber for helical gear. We develop single setup and then we modify for it for internal cylindrical surface, external cylindrical surface, spar gear, helical gear, and then bevel gear, and then it is also used for finishing bearings and going on. Okay, so this is a schematic. This is a photographic view of the setup, tooling system used for helical gear. This is workpiece, honing gear, and this is cathode gear. This part, this red part is copper gear, and the rest of the two parts that are made of bakelite. Bakelites are normally non-conductive in nature. This is the tooling system for bevel gear. In this figure, only single tooling is there. Okay, that only single. This part is copper, and this part is made of bakelite. Okay, this is completely honing. Okay, and this is done purposely so that we can, in a single workpiece gear, we can check ECH part, ECM part, and honing part. We can compare them. What is the surface finish of surface finish can be achieved by honing? What amount of surface finish that can be achieved by ECM? And what is the amount of surface finish that can be achieved by ECH process? That will purposely only single tool is used here. Otherwise, we have to use same tool in this side. Okay. There is short slots are there. We can just tighten these nuts and bolts, and we can move these blocks from this side to that side, end of this that's table, and we can accommodate different size of gear. This is the output. This is the initial condition of the gears, and this is the final part. This part, this whitened part, or this glazed part, basically is ECH'd. This part, this is abraded, only honing, single honing part. This is the 3D scanner output. We put the workpiece before and after the machining in the below the 3D scanner, and you take the image of that part. This is the initial condition, that these continuities are there. These are, and it is finished now. So these images have been taken by surface profiler, non-contact type surface tester surface tester, and the initial condition is RA is 6.8 micron, and after finishing we will get 359 nanometer, that is 0.3 micron. Okay, so almost 80 or 85% improvement can be observed in ECH process. These are same diagrams, 500 magnification and 1000 magnification, and this is after processing, it's 500 magnification and 1000 magnifications. This feed marks, micro cracks can be removed by ECH process. Some of the videos are there, just this is workpiece, and the visibility is a bit poor, I think. This is workpiece, this is tool, rotate the rack and pinion arrangement. Okay, and provide rotational reciprocating motion. Now it start reciprocate. Now it is in dry condition. The next video is for electrolyte supply. It will run or not?
So like you could do PLC table. Just click कर दीजिए.
Skip कर रहे हैं, skip. It's not working.
So like cursor copy लिख दीजिए.
ABI file should be run in VLC, I think. But VLC कर रहे हैं, VLC not working actually.
So वो नीचे कौन से?
VLC है Windows Media Player. Windows Media Player तो समझते हैं.
इनमें से कैसे कोई ये वाली है?
हाँ.
ऊपर तो शॉर्टकट बना हुआ है आपका वैसे.
This is ECH for spar gear for at wet condition. The final initial one is for dry condition. Here electric supply is also there. So this is wet condition. These are stepper motor is there to provide reciprocating motion. DC motor is there to provide rotating motion. This is an inlet pipe. The microprocessor kit to control the reciprocating motion of that workpiece. This is the power supply unit, this box. These are outlet pipes, this one and another one, that's this side, this one. These are outlet pipes. This is for helical gear. This is for bevel gear. So in this process that ACH, any question? Okay. In this SH process, that power supply unit is there, electro supply unit is there, and mechanical motion is there. So we have to choose the materials accordingly to fabricate the components. That the materials should be easily available. First of things, should be economical. Beside this, this should be insulation in nature, because power supply unit is there. If it's not insulation properly insulated, then we will get soft. Okay. And another thing is that for some of the materials, conductivity is a factor. If you use copper as cathode tool, the copper is selected as its conductivity is good. If you go for brass, or if you go for other material with rather copper, then you will get other result. So these things should be taken into consideration during designing or fabricating this setup. So the main advantage, moving to the advantages of this process. So increase material removal rate, particularly on hard materials and bar-free surface. Improves accuracy and threefold increase in the abrasive sections. The tool never comes in contact of workpiece and therefore zero tool wear. No spark is produced and the temperature generated is low, which does not cause metallurgical changes. If we check the hardness before and after the process, we will get the almost same hardness. And the hardness remains in the same range for before and after the process. So there is no mechanical changes can be observed before and after the process. So it is basically good for us, because we can only change the finishing process, or we can improve the surface quality, and during process there is no chance of altering the metallurgical or mechanical properties. But this process have obviously some limitation. This workpiece must be conducting this same for ECM, EDM, all the electrochemical or electro discharge techniques processes. Huge amount of energy is consumed, obviously. ECH more costly than conventional type because of its electrical and fluid handling elements, and the need for corrosion protection, because maintenance is really a problem for it. If we leave this setup for 1 and 2 months, then we have to just almost consume 2 or 3 days to ready it for the next operation. But it is good for production, long production runs, not for small production. And blind holes are not easily handled as through holes. Through holes can be done. Through holes can be finished by using ACH of cylinders. But for blind holes, we have to do some work. Still, we have to do some works. So the applications are This is some of the typical applications. Presently, GM is using this technique, ECH technique, to finishing the internal cylinders. And rather the GM, some of the companies are starting to just follow this technique to get better output or to get better service life of the components. So this techniques research is going on, and still lots of work has to be carried out, and some of them are listed here. That surface quality improvement has been discussed, but further study could consider weight test and fatigue test, typological properties. That has to be discussed because we are finished the gear part, but the main problem of gear is that fatigue failure. So we have to check the fatigue problem, whether it is improving or not. We have to check it. Okay. Then next part is that corrosional effect, because salt solution is used. The salt solution is having obviously corrosional effect, or it will obviously corrode the workpiece surface. We have to check the corrosional effect of electrolyte on workpiece surface. Magnetic field, magnetic assistance can be used to improve the process performance. To achieve real-time interaction or online monitoring, or we can model it by using finite element modeling or finite boundary modeling. So the key message of this presentation is that electrochemical honing is an electrochemical based hybrid machining process, and it is capable to provide micro nano level finishing to the cylindrical surface and gears, but it requires comprehensive study to be commercialized in industry. It is really a good process, very beautiful process, but we have to continue our study, or we have to check some, we have to modify it properly so that we can commercialize it. So these are the references. So before ending my session, I just wish to share a story, small story. That is, once in a village lived a wise old man, and people of his and all nearby villages went to him for his valuable advice. But few young chaps of the village could not take it and thought up a plan to prove the wise man wrong. They planned to take a sparrow hiding in their hand and ask him whether it is alive or dead. If he says alive, they will twist its neck and show it to be dead. And if it answers the bird is dead, and they will set it free. Thus, in any way, they will prove him wrong in order to create distrust among villagers. But to their surprise, the wise man answered with a chuckle that power is in your hand, and it's up to you how you use it. So this type of program is going on, but it is up to you how we use this output of this, how we can use it. We are because we have to execute it. Planning is there, so many plans are there, but we have to execute it. So it is up to us that how we are going to use it, this type of programs. So this is all about this presentation. I'm always available through this mail ID. You can, any type of doubt, any type of help, or any type of discussion is required, you can mail me. So queries are always welcome. So any query, any doubt, anything else?
Good afternoon, sir.
Very good afternoon.
Sir, is it possible to machine composite laminate with EC technique?
Sorry?
Is it possible to machine or machine composite laminate with electrochemical technique?
It is possible, but you have to modify it. Modify the process.
Is it based on the fiber and matrix we are using for composite materials?
Obviously. Composite is made of fiber and one fiber part and matrix part.
Yes,
So on
yes.
the basis of that, if it is conductive in nature, we can finish it.
Thank you, sir.
Thank you.
थोड़ा पूछ लीजिए आरडी इंजीनियरिंग कॉलेज से एनी क्वेरी प्रोवाइड
Ask them RD College. You have any question?
RD College.
RD Engineering College.
Any query from RD Engineering College? Any query?
I think they don't have any doors.
Any queries or any doubt? Siddhartha. Okay. Any queries from Siddhartha Engineering College?
No, sir.
Okay. Thank you. Thank you very much.
If you have any, you can interact. Otherwise, we'll end up the session.
सर ये जो टाइम कैसे पता लगाते हैं कि ये ऑपरेशन इतने टाइम में पूरा होगा मशीन चल रही है जैसे आपने
In case of ECH, okay. Time after you have to hit and trial method, nothing else. You have to check it. We have normally run for 10 minutes. Normal operation is 10 minutes. If you go for any grinding, it takes almost one and a half hour. To finish the same type of gear in ECH, it takes 10 to 12 minutes. हम क्या करते हैं कि स्टेप बाय स्टेप करते हैं. पहले 2 मिनट्स के लिए रन करते हैं, गियर को निकालते हैं, we'll check its surface finish, okay. Then because it's basically a finishing process, okay. So we have to check the surface finish quality only. So after 2 minutes, take it and measure the surface finish. Then after run for 2 minutes, then again. So after that we will just plot a graph. We got maximum significant amount of changes. That okay, it is going on. If this changes is not significant, then we'll cut down. Okay, no problem with that. This for first 2 minutes, 20% improvement is there. For next 2 minutes, 40% improvement is there. For next 2 minutes, that is 10 or 15% improvement there. Next, after 8 or 10 minutes, it is observed that the improvement is near about 4 or 5%. Okay, stop that. No need to that. Don't bother about that 4 or 5% improvement. Or you already get 70 or 80% improvement is okay. So, thank you. This is a modification of experimental setup. Just we are working on presently. Basically, we try to club one ultrasonic assistant with that to improve the performance of this technique. This is the work is going on. Yet to complete this work. So this part is basically this one.
तो ये नॉन कंडक्टिव मटेरियल जैसे फाइबर लैमिनेट उसके लिए कर सकते हैं कोई भी टेक्निक आई है क्या ईसीएम से?
नहीं, ईसीएम बेस्ड टेक्निक नहीं कर सकते हैं क्योंकि ईसीएम बेस का लिमिटेशन है कि वो कॉन्डक्टिव होने चाहिए. अगर कॉन्डक्टिव नहीं है तो हम नहीं कर सकते उस चीज को. ठीक है, जितने भी टेक्निक्स है, ईडीएम है, ईसीएम है, डब्ल्यूईडीएम है, उसमें अगर कॉन्डक्टिव नॉन कॉन्डक्टिव मटेरियल हम उस पर टेस्ट नहीं कर सकते वो चीज. बट अगर मटेरियल कॉन्डक्टिव है, मैट्रिक्स कॉन्डक्टिव है, जो फाइबर है वो नॉन कॉन्डक्टिव है, तो उसमें हम कर सकते हैं प्रोसेस को.
ऐसा कर सकते सर एक कंडक्टिव लेयर के बीच में दो नॉन कंडक्टिव लेयर हम ऐड कर ले, मशीनिंग के बाद फिर निकाल दें.
नहीं, फिर तो फिनिशिंग तो उसका होगा ना. नहीं, फिनिशिंग तो कंडक्टिव लेयर का.
हमें नॉन कंडक्टिव मटेरियल की फिनिशिंग करना है तो दो नॉन कंडक्टिव मटेरियल उसके बीच में कंडक्टिव मटेरियल आके ऐड करके फिर
बट नहीं, फिनिशिंग किसका होगा फिर? कंडक्टिव का होगा, नॉन कंडक्टिव का होगा? फिनिशिंग का कंडक्टिव का होगा ना. नहीं, जैसे डब्ल्यूडीएम करते हैं, एल्यूमिनियम सिलिकॉन कार्बाइड के कंपोजिट्स पे डब्ल्यूडीएम करते हैं, ठीक है. बट उसमें प्रॉब्लम क्या है कि हम एल्यूमिनियम बेस मैट्रिक्स है, सिलिकॉन कार्बाइड है. सिलिकॉन कार्बाइड नॉर्मली नॉन कंडक्टिव है, एल्यूमिनियम कंडक्टिव है. वो एल्यूमिनियम जहां तक कटता है, जहां पे सिलिकॉन कार्बाइड है, क्या कभी कभी ये प्रॉब्लम होता है कि वायर ब्रेकेज हो जाता है. कभी ये भी होता है कि वो कट जाए, थ्रू हो जाए. क्यों? क्योंकि जो हीट जेट है ऑलरेडी वो उसको मेल्ट कर देगा. एल्यूमिनियम के काट रहे हैं, सपोज WDM से हाँ वो चीज कर सकते हैं, वो पॉसिबल है, वो पॉसिबल है, क्योंकि बट उसके भी एक थिकनेस का लिमिटेशन है, क्योंकि डिपेंड करता है कि जब कॉन्डक्टिव मटेरियल कॉन्टैक्ट में आएगा तभी उसमें हीट जनरेट होगा। वो हीट कितने दूर तक पेनिट्रेट कर रहा है, दैट ओनली डिपेंड्स। वो अगर पेनिट्रेट कर रहा है और थिकनेस उस अमाउंट तक है तो वो हम काट कर सकते हैं नॉन कॉन्डक्टिव मटेरियल को भी, बट अगर थिकनेस ज़्यादा है तो वो पूरे में पेनिट्रेट करेगा नहीं, तो फिर काट नहीं होगा। जितने भी मेटल मैट्रिक्स कॉम्पोजिट्स हैं जहाँ पे सिरामिक्स एज ए फाइबर है, सिरामिक्स या पॉलीमर फाइबर है, वहाँ पे ये प्रॉब्लम है। पॉलीमर फाइबर है तो प्रॉब्लम नहीं है, क्योंकि पॉलीमर का मेल्टिंग पॉइंट इतने नहीं होते, तो हम इजीली काट कर सकते हैं। मेटल मैट्रिक्स है, पॉलीमर कॉम्पोजिट्स है, पॉलीमर फाइबर है, सॉरी पॉलीमर फाइबर है, तो हम इजीली काट कर सकते हैं। बट मेटल मैट्रिक्स है और सिरामिक्स फाइबर है तो वहाँ पे प्रॉब्लम होता है कि वहाँ पे जैसे अगर जो सिरामिक्स है, एल्यूमिनियम कार्बाइड, एल्यूमिनियम ऑक्साइड, सिलिकॉन कार्बाइड, वो है, वो अगर उसके जो क्वांटिटी अगर ज़्यादा ना हो तो जो हीट जनरेट हो रहा है उससे मेल्ट होकर वो मूव हो जाएगा, बट ज़्यादा है तो उसमें एयर ब्रेकेज हो जाएगा, फिर से हमें प्रोसेस को स्टार्ट करना पड़ेगा।
तो सर आपने बताया 40 डिग्री डायरेक्ट फ्लूइड का जो टेंपरेचर से आ जाता है नहीं,
ये ECH के लिए है, हम इलेक्ट्रोलाइट है तो वो उसमें डाइलेक्ट्रिक फ्लूइड यूज होता है। EDM में स्पार्क इरोशन होता है, वो उसका जो टेम्परेचर है वो 5000 से भी ऊपर जाता है टेम्परेचर डिग्री सेंटीग्रेड, 5 to 10,000 के आसपास, ठीक है। तो ये वो है टेम्परेचर है, बट प्रॉब्लम इज दैट कि हमें ढूंढना पड़ेगा कि कौन से प्रोसेस हमारे लिए बेनिफिशियल है और उस पर हम क्या मॉडिफाई कर सकते हैं। ये चीज मेन प्रॉब्लम है कि हम मॉडिफाई कैसे कर सकते हैं। डाइलेक्ट्रिक फ्लूइड inflammable, okay, it is not all case inflammable,
but even though spark arises there, why you are using that kind of material over there?
That temperature is not that temperature, that temperature is for a narrow zone or a nano zone, basically micro level, so that cannot take that inflammable substance to the melting point or burning point, not melting point but burning point, okay, because the erosion is occurred, sparks is occurred, okay. So micro level metal is removed, but we use kerosene. Suppose hydrocarbon oils, we use kerosene almost 80 liter or 100 liter. So we have to, if we wish to burn it, so we have to take that amount. Another thing is that that machining core is deep under under hydrocarbon, so chances of getting the oxygen is less, because for burning oxygen is required, so oxygen is not available there.
मिनिमम सब 3:1 से अगर कम है ऑक्सीजन तो वालों बर्निंग के लेवल 3
हाँ
कम है तो
बर्निंग होगा नहीं।
Other than dielectric fluid, what we can use here?
Dielectric कहाँ पे?
Other in EDM process.
नहीं, कोई ना कोई डाइलेक्ट्रिक चाहिए।
No, अच्छा।
एक्चुअली EDM प्रोसेस में क्या होता है कि कैथोड है, नेगेटिव एनोड है। नॉर्मली क्या है कि हम अगर किसी रास्ते से मूव कर रहे हैं, सिंपली अगर हम इलेक्ट्रॉन्स के मूवमेंट को कंसीडर करेंगे, क्या करेंगे कि हम किसी रास्ते से जा रहे हैं, निकले यहाँ से, अब रास्ते में एक ट्रेंच आ गया, नाला, नहर आ गया, अब हमारे पास 3 ऑप्शन हो सकते हैं कि हमारे लिए दूसरे रास्ते, नहर इतना बड़ा है कि हम क्रॉस नहीं कर सकते, देन वी विल फाइंड फॉर डिफरेंट वे, अदर वे। अगर ऐसा ऑप्शन है कि इजीली क्रॉस कर सकते तो हम इजीली क्रॉस कर जाएंगे। और इसके इन बिटवीन एक प्रोसेस हो सकता है कि हमें पीछे से दौड़ के कूदना पड़ेगा, ठीक है। तो इलेक्ट्रॉन्स, अगर दोनों में डिफरेंस है, इलेक्ट्रॉन्स का हमेशा मूवमेंट है कि इलेक्ट्रॉन्स नेगेटिव टू पॉजिटिव की तरफ मूव करेगा। अब गैप बना दिए, बीच में गैप बना दिए, इलेक्ट्रॉन्स क्या जाम करना चाहेगा। तो इलेक्ट्रॉन्स जब मूव कर रहे हैं, अगर पोटेंशियल डिफरेंस, वो पोटेंशियल हमारे पास एनर्जी होना चाहिए, जैसे हमें एनर्जी है कि मैं कूद सकता हूँ, तो पोटेंशियल डिफरेंस इतना है, उस इलेक्ट्रॉन के पास इतनी एनर्जी है कि वो कूद सकते हैं, देन वो कैथोड या नेगेटिव पोल से पॉजिटिव पोल की तरफ मूव करेगा। जैसे ही मूव करेगा जो बीच वाले पार्ट है उसमें डाइलेक्ट्रिक है, वो डाइलेक्ट्रिक के जो मॉलिक्यूल्स है उसको हिट करेगा, हिट करके वो मॉलिक्यूल्स पॉजिटिव आयंस और इलेक्ट्रॉन्स पे डिवाइड हो जाएगा। ये जो पॉजिटिव इलेक्ट्रॉन्स हैं, ये इलेक्ट्रॉन्स, वो इलेक्ट्रॉन्स मूव करेगा वर्कपीस की तरफ, और ये जो पॉजिटिव आयंस हैं वो मूव करेगा टूल की तरफ, ठीक है। अब इलेक्ट्रॉन्स के जो मोमेंटम है वो ज्यादा है, वो क्या करेगा, जैसे ही वर्कपीस को स्ट्राइक करेगा उसके जो काइनेटिक एनर्जी है दैट विल कन्वर्ट इन द हीट एनर्जी। उस हीट एनर्जी में टेम्परेचर राइज होगा, उस हीट एनर्जी से मेटल को फ्यूज वेपोराइज करके इवापोरेट कर देगा। ये है ईडीएम का प्रोसेस। बट जो पॉजिटिव आयंस हैं वो टूल को हिट करेगा एंड टूल को रिमूव करेगा, ठीक है। तो ये हमें चूज करना पड़ता है कि, बट टूल का रिमूवल हमेशा कम होता है देन मेटल रिमूवल से, क्योंकि जो पॉजिटिव आयंस है उसके मोमेंटम इससे कम होता है इलेक्ट्रॉन से। नहीं, पॉजिटिव आयंस की कम होती है। एक होता है कि वेलोसिटी, एक होता है वेट, और एक होता है नंबर। इन तीनों चीज पे डिपेंड करता है। तो वेलोसिटी और नंबर ऑफ इलेक्ट्रॉन्स ज्यादा है उसपे, चाहे पॉजिटिव आयंस का मास ज्यादा हो इलेक्ट्रॉन से, बट जो वेलोसिटी है और क्वांटिटी है वो इलेक्ट्रॉन्स का ज्यादा है, क्योंकि इलेक्ट्रॉन्स ऑलरेडी मूव कर रहे हैं। यहाँ पे आके इक्वल नंबर इलेक्ट्रॉन्स हुआ। वो बराबर निकलेंगे। बाकी जो इलेक्ट्रॉन्स हैं पहले से आ रहे हैं, वो कहाँ जाएंगे? वो भी तो है ही चैनल पे। तो इलेक्ट्रॉन नेगेटिव है, वो नंबर ऑफ ज्यादा है, इसके वेलोसिटी ज्यादा है। तो ये ईडीसी प्रोसेस है। अब
in electrochemical this process normally we use the tradition we follow negative tool positive workpiece. Can we change the direction?
then electroplating will be occurred.
Electroplating. Then it is not called as a non-conventional.
It is obviously it is non-conventional. It is not non-conventional machining technique. It is non-conventional coating technique.
Yesterday we had the same question, yes. But he said we can use the direction like negative tool positive workpiece. But if negative workpiece he told only EDM.
EDM के लिए पॉसिबल है, EDM के लिए पॉसिबल है, EDM के लिए बहुत पॉसिबल। टूल को हम पॉजिटिव भी कर सकते हैं, नेगेटिव भी कर सकते हैं, ठीक है, कुछ भी कर सकते हैं, उसमें कोई प्रॉब्लम नहीं है। हाँ,
we can change.
हाँ, बट
EDM में सर ये रिवर्स क्यों करते हैं? ये कह रहे हैं कि रिवर्स क्यों करते हैं? What is our motive? Basically, trade में तो क्या है कि we want to cut the workpiece. But if we want to reverse the polarity, so what is our aim? Particular application.
नहीं, एक्चुअली दो ऑप्शन है कि रिमूव, जो हम प्रैक्टिस करते हैं कि नॉर्मल प्रैक्टिस करते हैं कि हमें टूल को रिमूव कराना है। और टूल के मैंने जो इलेक्ट्रो डिस्चार्ज कोटिंग की बात की है, इलेक्ट्रो डिस्चार्ज कोटिंग की मैंने एक बात किया था कि ईडीएम है और इलेक्ट्रो उसको मॉडिफाई करके हम इलेक्ट्रो डिस्चार्ज कोटिंग कर सकते हैं। ईडीएम प्रोसेस एक है सिंपल प्रोसेस, जिसपे हम क्या करते हैं, टूल को करते हैं नेगेटिव, वापस को पॉजिटिव करते हैं, हम उसको काट कर रहे हैं नॉर्मल प्रैक्टिस, जैसे नॉर्मल प्रैक्टिस, ठीक है। इसमें दोनों ऑप्शन है कि टूल भी वेयर होगा और एमआरआई भी वेयर होगा, ठीक है। अब इसमें दोनों ऑप्शन में ये एक चांसेस है कि हमें कौन से पार्ट ज़्यादा चाहिए। हम अगर नेगेटिव पोल यूज कर रहे हैं टूल को, तो हमें एमआरआई ज़्यादा मिलता है देन टूल वेयर रेट। अगर हम इसको रिवर्स कर दें तो टूल वेयर रेट ज़्यादा हो जाएगा, बट वो हमारे लिए बेनिफिशियल नहीं है। एमआरआई उसमें भी मिलेगा, हाँ, टूल खराब होगा, वो हमारे लिए मतलब हमें जरूरत नहीं है उस चीज़ की। दिस इज नॉट माई एसेंशियल। मैं एसेंशियल क्या है कि एमआरआई ज़्यादा हो देन टूल वेयर रेट। जितने भी टेक्निक्स है, यूएसएम टेक्निक्स है, जितने भी टेक्निक्स हैं, यूएसएम टेक्निक्स है, एजीएम टेक्निक्स है, जितने भी टेक्निक्स है, उस टेक्निक्स में, सभी टेक्निक में थोड़ा बहुत टूल वेयर रेट होता है। बट ईसीएम में टूल वेयर रेट जीरो है, कंप्लीटली जीरो। एक टूल बना लिए, वो पूरे लाइफ के लिए, पूरे साल के, मतलब पूरे थ्रू आउट द 30 ईयर्स 40 ईयर्स के लिए यूज कर सकते हैं। ये उसका बेनिफिट है प्रोसेस का, कि हमें एक टूल बनाया, उस टूल को हम कितने बार चाहे यूज कर सकते हैं। बट ये देखना पड़ेगा कि उसका कोई एनवायरमेंटल इम्पैक्ट ना हो। सपोज ब्रास है तो ब्रास के ऊपर एक ग्रीन कलर का लेयर फॉर्म हो जाता है 2 दिन में उसके अंदर, तो ये ना हो। अगर वो भी हो तो हम ब्रास के ऊपर थोड़ा सा एसीटोन यूज करके उसे साफ करके फिर से यूज कर सकते हैं। ये बेसिकली ईसीएम का एक बेनिफिट्स है अदर एमपीज।
But we do electrochemical lapping also in the on your electrochemical lapping.
हाँ, obviously. हाँ.
That is also one kind of hybrid machining.
इलेक्ट्रोकेमिकल बेसिकली इलेक्ट्रोकेमिकल लैपिंग बेसिकली यूज होता है मेटिंग सरफेस के लिए। 2 मेटिंग सरफेस है, 2 गियर है, एक मास्टर गियर है, एक सम्प गियर है। दोनों के जो मूवमेंट हो रहा है, दोनों के एक ही ऑपरेशन में यूज करना है, ठीक है। अब उसके जो मूवमेंट हो रहा है, उसका नॉइज को रिड्यूस करना है, तो हम उसमें लैपिंग करते हैं। दोनों कंपोनेंट के एज इट इज एप्लीकेशंस में यूज करते हैं। हम कभी किसी एक सिंगल वर्कपीस को यूज करने के लिए लैपिंग नहीं करते। उसके दोनों सरफेस को, अगर मेटिंग सरफेस है और दोनों सरफेस किसी एप्लीकेशन में एट अ टाइम यूज होगा, तो हम लैपिंग के लिए जाते हैं। तो ग्राइंडिंग हो सकता है, हॉनिंग हो सकता है, इस जितनी भी प्रोसेस है उसको हम क्लब कर सकते हैं इस प्रोसेस के साथ। मतलब ग्राइंडिंग को, मतलब हॉनिंग को ज़्यादा प्रेफर करते हैं ग्राइंडिंग से। नहीं, ग्राइंडिंग में ज़्यादा रिमूवल होगा, बट ज़्यादा रिमूवल होगा तो कंट्रीब्यूशन का जो रेशियो है एसीएम वर्सेस मैकेनिकल एब्रेशन, इसको हम कंट्रोल करना पड़ेगा। अगर मैकेनिकल एब्रेशन का रेशियो ज़्यादा हो जाए तो हमें जो सरफेस फिनिश मिलेगा वो खराब मिलेगा। ईसीएम से ज़्यादा होना चाहिए। ईसीएम से ज़्यादा होना चाहिए क्योंकि वो एटॉमिक स्केल पे मटेरियल रिमूव होता है। आयन बाय आयन, इलेक्ट्रॉन्स बाय इलेक्ट्रॉन्स मूवमेंट हो रहा है, तो इसलिए हमें वो चीज़ को, रेशियो को मेंटेन करना पड़ेगा। ओके ओके, थैंक यू वेरी मच। डिलीट कर दें? ये प्रोवाइड करते हैं क्या?
Tomorrow we'll be providing CD to them.
ओके, नो प्रॉब्लम विद दैट। नहीं,
फोल्डर बनाया डेस्कटॉप में है ना? हाँ, उससे बता दो। डेस्कटॉप में ये में फोल्डर बनाओ शायद। हाँ, इसमें।
हाइब्रिड ठीक। पेन ड्राइव कहाँ है? चलिए पेन ड्राइव को रिमूव कर दीजिएगा।
Okay, thank you, Dr. Jayaprakash Mishra, for giving a wonderful lecture on electrochemical honing, one kind of latest hybrid machining process used for the gears as well as the internal cylinders, external cylinders. And you have focused even that latest, including the ultrasonic assistant for the electrochemical honing of gears. And now the time is over. Now actually the first session is going to be end. We'll meet at around, after the session we'll meet at 2 o'clock, and I request nodal centers also, please be, while session is going, please be there. Nobody is, I'm unable to see anybody here. In the art engineering college there is nobody is there in sitting. Can you hear me? Art engineering college? हाँ जी, आवाज नहीं आ रहा। माइक ऑन करो। Switch on the mic. Okay. सुनिए, आप यहाँ पे कुछ कोई भी दिख रहा नहीं, यहाँ पे कोई nobody is there. Please be there, at least minimum 10 से 15 लोग तो होना चाहिए ना, हाँ? And since 3-4 days I am observing nobody is sitting from art engineering college. Please try to be, when we are calling very good number of experts over here to deliver lectures, but nobody is attending. We are spending so much money for this ICT lectures, but you are not able to sit. During the session, at least you should be there, okay? And I request even Siddhartha Institute of Technology from Vijayawada also, please be there. You are, I am seeing only 5 to 6 persons. What about Prashanti madam? Tell me, what is the problem?
I am Prashanti sir.
Tell me madam, what is the problem? You are not able to understand the lectures. What happening? What is happening?
We are understanding, sir.
Then why the audience are not full?
They went to class.
No, please, at least during the sessions, when expert lectures are delivering, you should be there.
Okay.
I request you, it is only, this is fourth day. Tomorrow afternoon we have a very wonderful lecture on reverse engineering. Please try, don't miss the lecture afternoon.
Not getting your voice, sir.
That is reverse engineering topic, okay? Today afternoon 2 to 4 p.m.
आवाज नहीं सुन रहा है।
आवाज नहीं सुनाई दे रहा?
हेलो सर।
हाँ जी। Are you able to hear me, madam? नहीं, आवाज नहीं आ रहा उधर. Is there any bandwidth problem there?
Sir?
Any bandwidth problem? You are not. Are we audible to you?
మైక్ ఆన్ అయిందా మేడం? ఆపేద్దామా? ఇదేగా
Hello, 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 hello. Vijayawada, am I audible? Hello, hello, hello. 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 Hello, 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 hello. Hello, hello. At Vijayawada, am I audible? Hello? Sir, am I audible?
Yes, ma'am.
Okay.
दोनों हार्डली ठीक है ना? Okay, good afternoon, dear friends. Today we have invited Dr. Atul Kumar from SRM University, Ghaziabad, to deliver a lecture on reverse engineering. Just I want to give a brief introduction about his biodata. He has completed his BTech from UP Technical University. Then he has completed his MTech master program from NIT Surat, Gujarat. Then after that he has completed his PhD from Indian Institute of Technology, Roorkee, recently. He has done his research in the area of reverse engineering, and he is guiding many of the MTech students. And in his credit, he is having publications about 17 publications in his credit on international conferences, national conferences, and the international journals as well as national journals. So now I invite Dr. Atul Kumar to deliver a lecture on reverse engineering topic. Thank you.
Good afternoon, respected friends. I would like to say a special thanks to Mr. P.S. Rao. He say me that to give an expert lecture on reverse engineering. And also I am great thankful to NITTTR to talk to arrange this type of short programs for quality improvement in teaching. Now my today delivered lecture is on introduction of reverse engineering. The contents is introductions, definition of reverse engineering, methodology of reverse engineering, problem during data acquisition process, application limitations and advantages, one practical problems and conclusion. Then after future scopes. In generally, the design process is consists of following steps. Like before that, we have our problems. Based on that, we are going to first our need, what we required. Then after, based on that, we have required to design the data. After that, we are going to prototype and testing of that requirements and our products. Then after, we have a final products. But inside of reverse engineering, we have a product in physical form. Then after, we have going to the disassemble of that product in machine of a machine. Then after, we are going to do measure and testing. If there is any error in shape and size, then we are going to the design recovery using a design recovery. Then after going to the prototype testing, and then is a reverse engineering product has been recovered in this process or this flowcharts. The reverse engineering is defined as it is a 3D geometric data in the form of point cloud data using laser scanner, coordinate measuring machine, and etc. Reverse engineering has become a viable method to create a 3D virtual model of an existing physical part for use in 3D CAD, CAM, CAE, and other softwares. In construct to the traditional production sequence, reverse engineering typically start with measuring an existing physical object so that solid model can be created, make the advantage of CAD, CAM, and CAE technologies. The reverse engineering can also define as the terms come from the concept of directional data exchange between physical to digital worlds. There we have a physical models, this one, and we have some scanning techniques. Through that, we are going to the digitization of the existing physical object. The digitization of data is either in point cloud data format or in STL format. Now the methodology of reverse engineering is we have first of all physical objects and then any digitization techniques. It may be contact or non-contact types. Then we have data acquisition, means data scanning. Then we are going to pre-processing of scan data. Then we are going to segmentation of that scan data. Then creation of surface or curve and solid model of from the scan data. Then after this process is under the data analysis. Then after we completed the reverse engineering process up to till, then we are going to the reconstruction of a CAD model using these scan data, either by using point cloud data or either using by STL data. The application of these can be included for computer aided engineering system and for computer aided design system and for computer aided manufacturing system and for rapid prototyping purpose. After that, we can test the we can have a physical models and we can use its a performance testing of that. The basically reverse engineering is a digitization of existing object, and the final purpose is to create the CAD model of a existing object using any contact or non-contact scanning techniques. During digitization techniques, a data acquisition system includes both hardware and software. A hardware system is using a different scanning techniques such as contact or non-contact techniques. Method for scanning the object such as contact or non-contact methods. And software system is including the how to control the scan data, means how to remove the noise, how to complete the incomplete scanning data, and how to go to other steps which are necessary to create the accurate CAD models from the scan data. The classification of digitized data is contact and non-contact method. Contact method generally concluded as a tactile method. These are generally used in robotics to sense the object. Then after going to the purpose which we have designed the robots, and other contact method is coordinate measuring machine. It is a vital use in mechanical industry to scan the object. Under non-contact method, the basic principle is acoustic, optical, and magnetic. Out of them, optical method is now a very craze, and the triangulation method is more popular nowadays. So in generally the 3D non-contact scanner, the light triangulation method is used. After scanning, the problem is coming to the picture, the saving of data. How to save the scan data? The scan data can be saved in STL format or point cloud format. The difference between them is to point cloud data is give the x and y z coordinate information of scan data, that is in digital form. It's give a three columns values for x and y and z, and give a scan the data is as a stairs of the height of the object, like that. And the STL data means stereolithography format is a whole uh, object data format. Means we have scanned the object in a, and if we want to save in STL format, then we are going to whole object in STL format, means in its shows of surface model of that. But in point cloud data is showing the point cloud xyz coordinates, and the form of this data is very dense. So if we go to if we see it, it's like a surface, but it is actually not a surface model. It's a point cloud forms. After that, the scanning data have some noise, unwanted particles, etc. For we are going to remove these data and unwanted edges and etc. The process is called pre-processing and processing. Error occur in digitization process due to problem of unexpected light, reflecting edge, and invisible surface regions. Means when we are going to scan the object, there are some variation in voltage, currents, etc. Due to that, the model platform which we have placed it, and also the laser where is passed and the current is supplied, both are disturbing during that. So due to this the scanning data may go to the reflect. After that, reflecting edge and increasable surface region. Means if we are going to shiny surface of the model, then if we are going to non-contact laser scanner, in non-contact laser scanner there is a one laser beam. When we scan the laser, when we scan the object, the laser beam strike on the shiny surface and it has been reflect. Due to that, the accurate data can't be read by the laser. So it is a limitation of the non-contact scanner. The surface of the object should be painted by white coating. And other thing is increasable surface region. Means if we have some complicated surface like we will get, if we want to scan it, the proper surface we can't getting through scanning contact or non-contact or contact, both are. Then after, number of techniques are able to remove the scanning noise from scan data. Number of techniques are means there are some prepaid tool or some algorithm is available to reduce the scanning noise. If we are going to prepaid tool, there are some software or some scanning which are include in scanning 3D scanning. They have prepared its own tool to editing the scan data. Other hand, we are going to the programming, some image processing, follow by some image processing steps. So they give us some algorithm, and we can do it by algorithm also. Handling the dense point cloud is important for quality measurement, mesh generation, surface reconstruction, and simplification and segmentation. When we are going to the contact laser scanner, the number of scan data is too large, but we are going to the contact method. the number of scan data is less compared to non-contact method. So the quality of quality in case of reconstruction of 3D CAD model or geometry model is important task. For this, we are going to these steps, means noise reduction or pre-processing and post-processing, etc. The one method is segmentation and division of scan data. Segmentation is a divided the scan data into subset of the scan surface. There are two different approaches to segment the scan data. First is edge-based and second is phase-based. First order or edge-based segmentation is based on normal vector, which provide an initial subdivision of surface and detect properties sharp edge and curve area. In this, we have some mathematical surface and curve equations like Bezier and cubic, like that. We are correlate this data to that mathematical equation, and then after we have go to the accurate number of patches for which we have required to complete the CAD model, reconstruction of CAD models. While in second order or phase-based segmentation, subdivides the surface according to the principal curvature and provide a sufficient foundation for classification of simple algebraic surface. Means we are going to hear the some surface equations like Bezier surface, cubic surface, nervous surface, etc. The typical task is to create the CAD model from the scan data. These are, which I have discussed, these are the necessary steps to create the CAD model from the scan data using point cloud or STL data booths. The CAD model are also used throughout the reverse engineering process from 3D model and 2D drawing also. CAD model of physical component using point cloud data which have not available technical drawing and engineering drawing, and the surface creation of scan data using point cloud data, sorting the product lead time. Means if we are going to any process, it is a typical very typical task to generate the surface model or CAD model of existing object. But if we follow the reverse engineering, it is too simple to create the surface or CAD model of an existing object using contact or non-contact 3D scanning techniques. It directly sort the product and development times. Here we have some practical example which is given as some one researchers. He take a turbine blades and an example to use the reverse engineering. There is this is a turbine blade and it's considered as a damaged part. The task is to complete it a damaged portion using reverse engineering and some curve and some surface mathematical equations. Then after it's planned to create a prototype model or any physical model of that after doing editing work. The capture hardware and methods, that is which we have required the scanning tools or scanning techniques, the CMM, coordinate measuring machines, laser scanner, means non-contact 3D laser scanner, optic scanners, MRI, CGI, stereo scanning, and other modes also. After that we have physical model, and then we have some hardware to capture the data of existing object. Then after we are going to create the CAD model of that scan model, or in this case the turbine blade. For this we are going to some software like PC Damis, CopyCAD, and Pro Engineering. For this we have some sub steps. Generation of point cloud data means when we going to scanning the object, we have already the point cloud or STL data, but there are some steps such as segmentation, pre-processing, and noise reduction steps. It's after that it's called a generation of point cloud data, means noise free data. After that, we have a point cloud data. After that, we are going to generate the curves and surface of that scan data. After that, we create the surface and solid models from the scan data. After that, we have the 3D geometric model of that turbine blades, and this can be used for CAD system and CAM system and CAE systems. In CAD systems, what is the requirement of CAD system is that let us suppose this blade is defected from the whole assemblies and we disassemble it from that assemblies. Then after we are going to testing it, then using a CAD system we are going to assemble it in that particular portion where we have detected it. This is an application of CAD system. And CAM system, we want to require a physical model of this. Then we are going to the CAM system, giving some machining command and take some suitable material which is lower cost and give some machine instruction, and then it give a physical part of that scanned or dedicated geometric models. And like a CAE, for that model we are going to the static or dynamic analysis, means we have calculated statics and dynamic properties using any analysis software like ANSYS and APCAS, Neston, etc. There are some problem has been noted during the scanning process. Calibration. The calibration is basically indicate for the accuracy of the sensor. If there is a error in sensor, then the scan object is not properly. It show every time some error or some incomplete data. Then accuracy, it is a resolution of video system used. What the camera has been used to scan to capture the scan data, it's depend on this. Accessibility, this usually require multiple scan but can also make some data impossible to acquire with certain methods. Occlusion and flexing. This is there is some unwanted particle also available in scanning medium like dust particle and etc. These are reflect to the rays, and this directly affect on the quality of scanning object. And noise and incomplete data, due to some reflecting changes in voltage and currents, there are some incomplete, there is some noise and incomplete data is also in 3D CAD model or scan data. So this can be removed by use a multi-scanning method. Sometimes we are going to multi-scanning methods or multi-rays scanning techniques to avoid this type of problems. Then statistical disturbance of part. If we are going to any assembly part to scan it, then it is a problem to match the tolerance with the assembly parts or sub-assembly parts. Surface finish, the surface finish part being measured, smoothness and material coating can directly affect the data equations. As earlier told you, the shiny surface is difficult to scan the using non-contact method, so it's required some coating on that. The application of reverse engineering is basically divided in mechanical industry and film industry, chemical industry, and others. In mechanical industry, we are require some new design. If we have some old design and we want to change some its shape and size, then we are going to reverse engineering. And all part design, the drawing for particular machine assembly part may not longer to be available, and reverse engineering may be only way to produce drawing of such parts. Means the some parts is continue running in machine assembly, but due to some reasons we have not its drawing and other information regarding its drawing shape and size, then we are going to the reverse engineering. worn out and damaged parts. As we saw the example of turbine blades, it's a worn out parts. We are going to we are going to take its drawing and CAD models. So again we are going to the reverse engineering. Suppose we are going to the inspection purpose of the mechanical components, then we also use the reverse engineering. To in this we are going to capture the surface of both of model, first one and second one, and we use the data, scan data, for comparison. A replication, the drawing will not be available for such component. If required drawing must be created by reverse engineering. If we want to replace some parts, then we again go to the reverse engineering. And other application is also to assess a competitor product. Means there is some XUVs vehicle is also available in road, and one company is made it after a few days, second company also made it using scanning techniques. They have captured the outer surface and they have edited oven way or oven software. This is a way to create fast and very fast to develop the new cars. To analyze the working of products, means if we are going to some complicated assembly and we have we want to analyze the working of that during some after some editing in shape and size of that particular components, then we are going to analyzing the working of product using some software or some practically application. To identify potential pregnant environment, the application of reverse engineering in film industry. Animated objects are imported motion using the reverse engineering human escalation. Software engineering, to extract the design and implementation of a programs. It's also used in IT or CS branches to implement the programs. Chemical engineering, to determine the chemical compositions. If there is some information has been missed regarding particular components, then we are going to the basic steps in reverse way. Then is also the use of reverse engineering. And today is most vital field is medical field, to replace the dental teeth and knee and some backbone etc. like these parts, we can use the reverse engineering. Advantage of reverse engineering is because of flexibility in operation, we can use it frequently. Reducing the tooling cost, there is no material and like this to running cost is going to high and etc. One time purchasing is one time purchasing cost, then after we use it many years. Easy to adjustment of machine, there is no particular adding running cost for that, easily adjustable. Two equipment is there, one is computer and another one is machine, in both contact and non-contact methods. Low inventory or fast prototype production, means if we are going to the prototype and it is too fast, directly we are going to the scanning the object and take it a prototype model. The limitations is reverse engineering cannot be applied to all equipment, means if we are going to the too much complicated assemblies, then we are not going to it, because we have only two scanning techniques, non-contact or non-contact. Contact scanning, we require some space to touch the object, and non-contact scanning technique also requires some space to touch for rays to touch the object. If the too much complicated assembly, we can't do this. So it is a limitation of that reverse engineering application. Modification depend on point clouds. Means if we are going to modification in existing object and doing some modification as per our requirement, it is totally depend on the point clouds, means number of point clouds data. how much number of point cloud data has been scanned and how much they are how much they are accurate. It is a critical steps to handle the point cloud data in reverse engineering, which is special for using non-contact scanning techniques. Shiny surface is difficult to scan using laser scanner. Means if we have a very shiny surface, then it is difficult to scan. It requires some coating to finish this shiny surface. And I will talk to you that one practical problems. We have a 3D laser scanner, and this is a spur gear. 3 model is there. One is original gear, this one, and this one is worn out gear. And this is a CAD models which we have created using design data. And this is a 3D printing setup. We have scanned the spur gear for both original and worn out gear in using 3D non-contact laser scanner. We have fixed it on the rotating tables using some fixture or etc. After that, this is a design detail of spur gear what we have designed for physical object and also for CAD models. Then we are going to the scanning of that spur gear with following data. The 3D laser scanner Roland LPX 60 has been considered to scan this surface spur gear. There is some parameters which are required to scanning this spur gear. The parameter is number of planes, width pitch, height pitch, and phase angle and aspect ratio. Number of planes means if we want to scan this bottles, it is put on the scanning tables, and this is preview has been taken by the scanner. This is take a bottom and upper portion of that bottle, and automatically is divide the number of planes, or we can enter manually. Suppose if the number of scan plane is automatically has been taken by 15, and if we want to more number of planes, then we are enter it manually, that is 20. The difference between them is the point cloud data is more on 20 number of planes and less for 15 number of planes. The more number of planes, the 3D geometric model is more accurate, but the limitation is always there for a scanner. I can use the laser scanner. The limitation is 20 number of planes. We can't go up with it. Then after width pitch, it can be changes up to 0.4. Same is height pitch, it can also changes. The face angle, which the angle is where the laser can be strike to the object. It is that angle the laser is strike to the object. Then after aspect ratio, it has been fixed. It cannot be changes. The based on these five combination, we have scanned the object means spur gear, and we find and we conclude that these are the 5 pictures for different parameter, different these combinations. We can see the these some edges, these and these error noise, scanning noise, and these unwanted some edges like this. These are always present in the in non-contact 3D laser scanners. We can't remove it during the scanning. So we have doing 5 experiments to scan the spur gear, and we have find that the less number of noise is in number 4, means it This is we have the data. Number of plane is 20 and the phase angle is 80. More is basically is depend on the accuracy of that is on 18 phase angles, 80 degree of phase angle. After that we are going to the pre-processing of the scan object. This is a the image is a pre-processing. After the pre-processing means the some noise has been removed under pre-processing steps. This is has been done by the prepaid tool on the scanning software, which is included in adding scanning softwares. After that we have saw this pre-processed image in different views: top view, front view, side view, and perspective views. And the noise is too much less, but it is not a clear. There is some noise is also presented. Then we are going to the segmentation process. For this we can divide it logically surface into subsurface of scan data. Here we have divided these 12 teeth into individually teeth under segmentation process. We have segmented is for a particular teeth. Then after we are going to the segmentation programming. This is the height of this tooth is 1 to 14 mm, and we want to the point cloud data is coming with each and every height, means varies with the Z. Suppose this is our bottle. We have scanned it 40 number of planes. We want to take a data for Z is equal to 1 mm, 2 mm, 3 mm, and 4 mm, 5 mm up to 14 mm. This data has been detected using these algorithms. That is under come to the segmentation programming. By this we have detect the data for individual heights. The matrix is for this data has been for original data. For original gear, the number of data, total number of data for 12 teeth is like this: 55,22,088. Value of Z means height of the gear is 14 mm, and the number of scan surface for single tooth is 20, and the number of data is 32,941 for 14 mm. But here for single teeth the number of scan is 20 scan surface plane, and the density of scan data is 505 only for value of Z, that is 1 mm. We have going to the segmentation of this data, and we have find out the number of scan data for a particular value, that is Z is equal to 1 mm, and the number of data is 505. Same we are going to the wear out gear, means worn out gear. For these we are going to the inspection purpose for the geometry, change in geometry due to the wear in gear teeth. We have going to this. For this we are going to two aspect. First one is using the point cloud data, and second one is using the STL data. We are changing this data into point cloud data and STL data on ProE software. Then we have find the first image. These two images is for original gear, means before wear and after wear, has been created using point cloud data for all 12 number of teeth. Then after this is a second, this before wear and after wear is the images are using a STL format. The difference is when we are going to the STL format, it's give a surface model, but we are going to the point cloud data is give the 2D drawing. This method we are used to identify the worn out portion between these two teeth in terms of volume and area. For this we are compare these geometries for using point cloud and STL data both. For point cloud data we using some origin software, and for point cloud data we going through ProE tools. That is a one special tool is in ProE software. That is a reverse engineering tool. We directly import it in STL format, and we consider and select the reference plane. This, if we have a accurate data, then the plane and then the surface geometry is compare accurately without any doing extra work. If there is some error in scanning or etc., we can't do matching these profiles. We have calculated the area and also in terms of volume, the worn out space between these two teeth profiles. Then after we are going to the recreate the CAD model of that scan model. For that, we are going to segment the data for each and particular value of Z, that is height for 1 mm, 2 mm, 3 mm, 4 mm. Here we have considered the for 0 mm, 2 mm and 4 mm by taking the fraction of 2 because of too much data is there. Then we are going to recreate the CAD model. For this, we have saved all these segmented data into the point cloud format, and this data has been read by any modeling software like ProE and CATIA and SolidWorks and ANSYS. Also is there an option to read the STL format and scan data. We have considered the 20 number of 40 number of datum planes or 30 number 7 number of datum planes. Then we are import the point cloud data, and this data directly give to these teeth profiles. For make the 3D geometric model, we are going to the loft command. For this, we are going to the loft command for making the 3D geometric CAD model. In loft command, we loft all these curves and select these profiles and go to complete the loft command. Then we have this 3D geometric model of the scan spur gear like this. This application is the recreated 3D geometric model can be used for FEM analysis using ANSYS workbench. We have some initial boundary condition and etc. to fulfill the requirement of the static analysis of the spur gear. In the analysis of spur gear is we are going to the static analysis, the presented stresses on the tooth during the meshing or loading and unloading. The rebuilt CAD model is divided into irregular meshes, and total count element is 2132. Finite element method is used for analyzing the stress of original worn out recreated spur gear tooth. There is some values which have calculated based on the AGMA design handbooks, where we have considered some mathematical aspect through that. The radial force is 455 newtons in x direction, and tangential force is 1250 in y direction for transmitting the 4 kilowatt power at 1400 rpm. The various value force obtained both in x and y direction under distinct percentage of the predefined load, and some define the boundary condition like that. And we have finally go to the static analysis of a single tooth for wear out and original gear, which has been recreated using scan data, means using reverse engineering approach. We have compared the results, and we have found that the where is the cross section is less, the stress is more. That is the worn out tooth is passes through the more stresses, and this has been shown in graphs also. After it, we are going to the static analysis of a gear with some assembly also. With original gear, that is a design model, and pinion we have considered for 12 number of teeth, that is a recreated model. For this, our purpose is to identify or justify the results which we have got the recreated model or using reverse engineering approach. The recreated original worn-out CAD model of pin is important in SolidWorks to complete the assembly task. The recreated model original CAD model has been assembled with healthy gear tooth and contact region defined on any tooth surface, and the worn-out pinion CAD model has been assembled with healthy gear tooth. To contact region of worn-out pinion is defined between worn-out tooth and healthy gear tooth. Here we have considered three cases. First one is both gear and pinion has been design model. Second one is pinion is recreated, but there is no wear, and the gear is healthy again. Third one is the pinion is between tooth is worn out, but the gear is again designed gear. So there is a three cases we have studied. For this we have these cases: recreated original pinion CAD model with gear CAD model, recreated original pinion CAD model with gear CAD model, recreated worn out pinion CAD model with gear CAD models. We check this assemblies, it is working or not proper for all three cases. These first, second and third is for a recreated pinions. We have judged here that we are going to right direction here till here. These are the some conditions which are required to go to the FEM analysis of spur gear using workbench. There is some boundary condition and etc. is there. After that, we are going to the some boundary condition is also there. In first one, there is a contact between the teeth, two teeth. We have defined in ANSYS also. There we have a worn out tooth contact with healthy gear tooth, and we have defined this here in ANSYS workbench. The contact region means it is a surface defined. Basically, the surface defined surface has been defined in ANSYS workbench for the analysis purpose for a particular teeth during the meshing. And these are also some mathematical aspects we have calculated for Hertz equation, AGMA and Lewis, Hertz and AGMA for contact, and Lewis and AGMA for bending equations shown in table. And these are the results which we have got using this analysis for recreated pinion. After that, we have finally take these results for compare this data for CAD model and for reverse engineering wear and original pinion model. This we have studies. The mathematical formulation by using Lewis equation is bending stress is given by 59.00. AGMA equation given is 65, and using FEA which we have model using design data, that is 66.63, and that second one is recreated original model that we have using reverse engineering created by using reverse engineering, that is 63.62, and the recreated worn out model, that is we have stress is 75.13. The result is to justify for using the stresses which we have got using reverse engineering approach. So here we can say that our reverse engineering approach is justified for this calculate the stresses and recreate for the recreated model which we have selected. Same for going to the contact stresses in same manner. Then one is application is more is prototype. We have prepare a prototype model of for all these three cases. First one is CAD model, second one is recreated original model, and third one is recreated worn out model. And we have doing some experiment to check out the dimension of gear, that is a geometrical parameters. It is a approximate same for physical model and the CAD model, and these all three cases there is no much variation that we can say it is not a working proper. No, it is approximately good results has been shown. The conclusion is reverse engineering has changed for a manual procedure to a sophisticated engineering process, utilize modern digitizing equipment and advanced CAD systems. In order to obtain adequate CAD models in surface reconstruction of the basis, 3D digitization data often results are satisfactory for CAD model after pre-process of scan data. The entire study involved object selection, digitization techniques, processing, pre-processing, and scan model reconstruction and CAD models. In industry, short lead time is demand to satisfy this type of work. As a result, the application of reverse engineering gaining the product speed and largely decrease the product design and deployment cycle time. As a result, the application of reverse engineering have been greatly extended for the original concept of making an exact copy of a part. With the advent of reverse engineering and rapid prototype technology in commercial and domestic use in manufacturing, to desired product will be regulatory in coming times. Future scopes. The application of reverse engineering techniques for measurement of more complex serviceable worn-out machine element and study their influence of operating parameters on performance characteristics has been conducted or to be conducted. The method can be extended for studying the effect of bending and contact stress for worn-out machine elements, and also going for fatigue analysis and some stiffness calculation or etc. The high allowable strength material can use to machine element either for same or in different working condition using reverse engineering FEM approach. Stiffness is another critical parameter that can be considered in the further work for worn out object when determining the force distribution during working of machine elements. Reverse engineering could be considered for analyzing the effect of adding high strength material coating or worn out portion to increase the life of worn out gear or worn out machine elements. Means the reverse engineering is using to coating the coating the surface on a metal on a component to become the hard surface of that one. The references and please give me.
सर आप सेंटर कॉल कर दीजिए सिद्धार्थ विजयवाड़ा कॉलेज में एनी क्वेरी फ्रॉम विजयवाड़ा
Yeah, please. Any query from the Vijayawada?
No queries, sir.
Yeah, ma'am. मैम आवाज नहीं आ रही है.
No queries, sir.
Okay, ma'am. Thank you. Ma'am, other place? RD. जी 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 हाँ सर सर एक्चुअली जो हमारा पर्पज था वो ये था कि इसमें जो मॉडल है उसमें कुछ ब्रोन आउट हो गया है, जो बियर होती है उसको आइडेंटिफाई करना है कि कितना बियर आउट हुआ है स्कैनिंग करके जी दैट इज अ इंस्पेक्शन एप्लीकेशन ऑफ रिवर्स इंजीनियरिंग कंपेयर पे ज्यादा किया आपने कि और भी सर कुछ भी एलिमेंट ले सकते हैं मैंने जस्ट प्रैक्टिकल एग्जांपल दिया हुआ है आपको किसी भी चीज को कर सकते हैं जिसकी डाई बनानी सॉरी सर ये नेक्स्ट ऑन सर एनालिसिस कर सकते हैं सर उसको नेक्स्ट ऑन वेलकम सर फ्यूचर स्कोप ये सर Sir, it's a ways called etc. But if we are going to the proper assembly, then we are going to other. Sir, the recent application is the automobile company is doing a reverse engineering for every new cars. They, yeah, for copying purpose. One night, only one night time is for they scan the whole body and modify it. Next, within a year they have. So the recent application is going to reverse engineering is to rapid prototyping more. Yeah, because there is some old machine is also available in industry and they can't change this machine because it is too reliable. They have, if they want to replace any one parts, they take a scanning and go to the prototype and again testing it. And the coating application is on a gasket. We doing some extra coating or hard material, and it give a long life. It is also using a reverse engineering.
और फिर क्लिप वगैरह है
कहाँ पे? नहीं सर, अभी नहीं डाला होगा मॉड्यूल। यहाँ आ गया मैडम मॉड्यूल में। हाँ सर, लगी हुई है। किसमें? सर ये पीपीटी आएगी कहाँ से? नहीं आ रहा मैं।
जो आपको चाहिए उसमें टैब प्रेस करते हैं।
कुछ पूछना है आपको?
नहीं, हो गया ना आपका?
हाँ।
Okay, thank you, Dr. Atul Kumar, for giving a lecture on reverse engineering. आपने नोडल सेंटर से बात कर लिया ना? Okay, today we'll stop here only, and tomorrow, that is the last day of the short term course. Tomorrow we'll meet sharp at 10 o'clock again, huh? And I request nodal centers also, they should come at 10 o'clock sharp. Okay, thank you.